It's been a while. It's been quite a while since I did a live stream. Um, what? Maybe. Oh, Happy New Year, Dimitri. Happy New Year. Um, yeah, it's been a while. Also, how has everyone's Christmas been and New Year's? Mine, not terribly well. Let's just sort this whole thing out. So I've changed camera angle, as you can see, because I've got two monitors, one on top of the other. Because I'm going to be doing some media production stuff, so I needed a second monitor. So that's up there. I've moved the camera a bit so you can kind of see the edge of the monitor here. Um, Done a few bits with the background. I've moved my microphone. Um, I am going to be coughing a lot because I didn't have a great Christmas because I have been rather sick, unfortunately. Um, I think it was 2 or 3 days before Christmas. I picked up the flu virus. So for the entire 5 days since before Christmas until I think the 28th, I was literally in bed for all those 5 days, apart from getting up to the toilet and getting drink and maybe a little bit of food. But yeah, I was so ill, and I'm still not over it. I've developed a bit of bronchitis, so not a terribly great start to the year. Well, not a terribly great end to the year, but last year can do one because it was rubbish. Um, yeah, I can see myself up there. I've got nVidia playing on the screen below there. Um, so yeah, let's get this party started. I do have some rum and coke. I'm actually drinking Captain Morgan today. So this is Captain Morgan dark rum. It's a little bit. It's not as smooth as the rum that I normally have, and it doesn't particularly taste great with the strawberries and cream Pepsi that I'm drinking right now. But it's fine. So apologies if I keep coughing. Like I say, I am still not terribly well, but there's nothing I can do about it. Um, I'm trying to. Okay. Just bear me a second. I can't seem to move my chat box. Never mind. Okay, so I'm going to crack on with the makeup. nVidia Jensen is going to start talking in about 50 minutes on stage at CES, the Consumer Electronics Showcase. I've always wanted to watch it live, never done it before. The reason I wanted to watch it is for the main reason being, you know what? I'm going to start doing the whole makeup thing while I'm yapping away. Raymond, yeah, that's you. Say just in chat saying your own name. So, put my ears on. Not that I need it because my hair is kind of slicked back at the minute. So, but it keeps the hair out of my face if it ends up being all over the place. So, the reason I wanted to watch nVidia at the Consumer Electronics Show this year is for this very reason. For the last 8 years, I've been rocking this bad boy in my studio computer. It is in here. The card that I've been using is in this box. I'm probably going to sell it. But yeah, GTX 1080 Ti, amazing card. nVidia have literally just now stopped supporting this. So if I knew that beforehand, I would have sold it a little bit earlier. But there you go. You have such a cute. Such a cutie. You have a nice day, beautiful. Thank you. I am going to have a nice evening. Like I say, I've not been very well over Christmas, so um, I've had flu. I've been in bed for 5 days. I've still got a bit of bronchitis, and I've not been able to enjoy myself. Not been able to see family. I've not been able to do anything at all. So I'm having some rum and coke, and I'm enjoying myself, dressing as a woman, and watching the nVidia keynote at Consumer Electronics Show. So yeah, this is what I've been rocking in my PC for the last 8 years. GeForce 1080 Ti. Barely used it really. I've not really ever clocked it or anything. Just shoved it in and basically forgot about it because I was doing basic editing stuff. So I've not really used it that much. So it's in decent condition. I've still got the box and everything. However, in my computer right now is this bad boy. Oh yes! Look at this! Oh! So I bought this just before Christmas. I was in a kind of a delirious state at the time, but this is basically a Christmas present. I did put maybe £100 towards it, but this is basically a Christmas present. GeForce 5070 Ti. It's the overclocked version of the Asus Prime card. So yeah, the reason I bought this is I've wanted to buy it for the last year. Not been able to because I've had to move house. But I wanted to get this because I want to do some semi-professional editing, video editing, for a project that I'm working on. You may have heard me talk about it. It's called Power of the Daleks Reimagined. I'm going to do a remake of it kind of thing. Sort of a remastering really, from the ground up, because I worked on it when it was released and I wasn't happy with my work, so I'm going to completely remaster it from the ground up and see what it's like. So this is a card I got. I paid, because Christmas, £699 for this. Now, considering the news that we've just had regarding memory issues, the price of this, since I bought it at £699. It has gone up to £799 at the minute, and nVidia have stopped producing these, have like completely cut production. So I know there's some German sites that can't get these anymore, so they're unable to sell them. The store that I bought this from, Overclockers in the UK, still have stock of this, but they've increased the price by £100. Yeah, it's a damn good card. It's almost exactly like a 1080. Sorry, not a 1080. It's almost the exact same card as the 5080, only it's clocked slightly lower, and it's got one less video encoder, which is fair enough. But yeah, I'm really happy with this purchase. I've been playing Oblivion Remastered. I want to install Cyberpunk 2077 because I want to play it with RTX. Like I said, I've been rocking this for the last 8 years, and this can game fairly well even today. I can play Cyberpunk on fairly reasonable settings with this card, even with the outdated drivers. Now they've stopped supporting it, but now I've got this, I can play it how I want to play it. But the main reason I got this is for like semi-professional video editing that I want to do. So happy. £699, can't complain. The price is only going to go up. If you're in the market for a graphics card, I would highly recommend buying it now. Otherwise, you're going to be stuck because prices are going to increase because of the RAM shortage. Speaking of RAM shortage, before I moved house, I bought this. Obviously, the RAM isn't in here; it's in my computer. But this is a Crucial DDR4. 64 gigabytes, 3200 clock speed. I bought this from Amazon. It was, what did I pay for it? £95. Crucial is developed by Micron. Micron have pretty much destroyed the Crucial brand. They're not doing it anymore, and because of the memory shortage at the minute, this has literally doubled in price. So very lucky to buy it when I did. I've also bought a new SSD drive. This is a Crucial again, Crucial P310. It's a PCI Express Gen 4 drive. My motherboard is an AM4 motherboard, so I don't really need a Gen 5 drive unless I'm considering future proofing. But I'm not, so screw it. And it's nearly 20 past 8. I've got 40 minutes to do all the makeup and everything. Jesus Christ. So if you're watching this, thank you for watching. I'm going to do the makeup, transforming into a woman and all that kind of crap. Because that's what this channel's all about. So yeah, if anyone's got any questions, let me know in the chat. I can see it just here. So yeah, I'm going to crack on. Can everyone hear me okay? Is it all okay? Oh, I'm not entirely sure I like that rum. So I normally have Co-op rum because it's nice and smooth, and it's the same percentage, but it really works with Pepsi. But that one doesn't. I am already dressed, by the way, so you can probably tell. Trying to streamline everything. So, first thing I'm going to do is primer, as always. Oh, hello. There we go. So if you're a guy and you're doing makeup, you always need primer, especially with someone like me who's got oily skin. Primer is an absolute must. Nah. Oh God, I don't I don't know how I can do it. Sorry. Oh God. Oh, lovely. I've just realised I've not got any paper towels, and I need that for my lipstick. Oh, I'm gonna have to go downstairs and get some. Okay, I'm just gonna go downstairs and get some paper towels because I need some while this is drying. So let's put some music on. Something quite short because I'm only going to be like 2 minutes. 1 minute 45. There you go. Star Fox. No Twitch multi-stream today. No, I've reinstalled everything on my computer, Will. So I haven't been able to set up multi-stream at the moment. Is that even straight? There you go. So yeah, no more to stream today. I will set it up though for the next time I do streams, so I can stream both on YouTube and Twitch. But yeah, no more to stream today, unfortunately. I've got a different card in my computer. I'm not using the Elgato card today. I'm using I think it's called a I can't remember what it's called, but it's slightly better than the Elgato card. So I'm using that. Anyway, I'm just going to go get some paper towels so I can do my makeup properly. I will be right back, and I'll leave you with this little beauty. Okay, 1 minute. Is that even playing? Yeah, it is. Oh, that was well timed, wasn't it? Very well timed. Good. I am all set now. I'm all set. I'm all good. I don't know what. Oh, sorry. Oh dear. I'm still not well. uh, right, let's crack on with the makeup. Right. I think I've laid everything out all right. Oh, I forgot to get... I need a new one of these. Oh, it would help if I set my mirror up, wouldn't it? There we go. Oh, you can see it now, look. You can see my mirror. You can see how crap it is. Look at this. It's supposed to be that colour. Never mind. Right. Yeah, I really need to get a new one of these. Eh? Sexy. I kind of wish I set up multi-streaming before I started. I didn't really have time because I had to install OBS, and I didn't realise how much stuff I had to set up, like the boxes and the donos and all that kind of stuff. Ugh. I am feeling a little bit better, to be honest. Yeah, I'm not coughing as much as I was before. Like 2-3 days ago, I was coughing like crazy, and I don't feel quite so as ill as I have been. But that's flu for you. But also, you know, um, I've developed slight bronchitis, which is fantastic. It's so fantastic. Right. And what time is it? Oh, I think I've got enough time to do this. If I sort of speed run it, we might be able to do it before Jensen goes on stage at CES. It's all good. YouTube just has a very long chat delay. YouTube, innit? I mean, YouTube's gone downhill a bit in the last a couple of years. All it's going to take is for some business to come along and do something amazing with video, like a YouTube video thing, and everyone will migrate to that. It's not gonna take much if YouTube keeps going down the route they are. I mean, even the big boys have noticed how difficult it is to get a viewership going, even for just like, you know, normal upload videos rather than live streams. Like when I'm like browsing YouTube, I see like videos that are completely random from people that I've never, not even subscribed to, like people that have got like a few views, like 10 views. I'll see a video like that, and I'm all about like supporting new creators, but quite often it's like people that have like the topic is well like completely out there and not even something that I'm interested in. Occasionally I'll get something like, sometimes I watch retro gaming channels, because I'm all about the N64 and all that kind of stuff. But yeah, like these channels that have got only like 2 subscribers and things like that, sometimes I'll watch them to see what they're like, and most often than not, it's just some kid in a bed. Well, I say some kid, like 20 years old or something, in the bedroom, like just making videos, and I do appreciate that. I mean, you've got to start somewhere, but put some effort into your videos. I don't want to see videos where people haven't put effort into it. Like when I first started making videos, I put so much effort into the editing of it, and there is a lot of people out there that just like do what other people do and just try and get away with it. I do like my new monitor setup, but let me show you. Let me show you in the mirror, so you can probably see. So, hang on. So that's my main monitor there. You can see the nVidia thing going on, and then I've got another monitor up here with me and the chat box thing. It's all good. I like it. It's that monitor is essentially for when I'm doing professional video editing. So I've got a sort of reference monitor. It's a if anyone is interested, it's a Dell 2408 WFP. Pretty decent monitor. What am I doing? Don't know. I am doing my foundation. Here we go. That's nice. It is nice. It's a nice setup. I bought the stand for this monitor setup like months and months ago, but I've not installed it until like I was ill. When I was getting better, I realised that I am so incredibly bored. Like being in bed for like 5 days straight over Christmas and not being able to see anyone or do anything, like kind of took a toll on me. And even though I was still ill, I wanted to do things around the house that I've been meaning to do. So I've installed this 2 monitor setup, and it works. It works pretty well, and I'm proud of it. What am I doing? Starting down here. There we go. It's been so long since I've done this, I've forgotten how to do it. This might come out really rubbish. just so you know. This might just be terrible. It might be the worst makeup I've ever done, because I think the last time I did this was the last stream I did, which was about 50 something days ago, according to YouTube. It was when I did the whole reinstalling Windows on my laptop thing, which went really well, but the stream cut off because I think OBS crashed. I don't know why OBS crashed, but it did. which was annoying. So, everyone that's watching, are you watching the nVidia CES show as well, or are you just wanting to watch it via my stream? Or are you just wanting to watch me put makeup on and transform into a girl? I mean, that's the majority of my audience, I guess. Mind you, having said that, there are a lot of people that watch this and just hate watch because I've seen the comments, and it does tend to happen. But they didn't understand that this is all an entertainment thing. I mean, as much as I support LGBTQ and all that, what I'm doing is just for entertainment purposes. It's kind of different. It's more sort of a drag thing than a trans thing. I'll be honest. But I don't really like the way that drag artists do the makeup. I'm going to be honest with you. It's a bit over the top, but I think that's the point, isn't it? Because it's an act, and everything has to be over the top and crazy. I didn't even know there was an nVidia talk today. Yeah, it's the Consumer Electronics Showcase in Las Vegas. There's nVidia. I think they start at, well, in the UK GMT, they start at 9 o'clock, which I think it's 1 o'clock Pacific time. I think. And then, if I feel like it, at 11 o'clock GMT, which is UK time, Intel are going to be on stage. So I might stay up and watch that as well, depending on how I feel. Probably drunk. Yeah, we'll see how it goes. We'll see how I feel. And then we'll watch the nVidia showcase as well. Because I imagine... Sorry. I imagine... sorry, not nVidia. Intel. We'll watch the Intel showcase as well. Because I'm guessing, because of the way nVidia are going, Intel are probably going to be showcasing their new GPUs, which everyone's kind of interested in because Intel have just gotten into the GPU market with, I think the current one is Battle Mage. And if all goes to plan, I'm hoping that Intel does really well with their GPUs once they've matured. God, imagine just talking for like 2 hours just before nVidia actually gets on stage. That's what the nVidia Live thing's doing, right? Well, let's listen in.
Involved of how to approach this problem, but technology is moving fast, so I'm an absolute technology optimist on this. Coming to a road near you soon, at least if you're driving a Mercedes.
Well,
It's all AI. It's all fucking AI. It's all nVidia talk about these days. AI this, AI that. They don't talk about the fact that companies are in debt because of AI. But what do I know? I'm just a humble guy, just doing wholesome streams and How do I look, by the way? Am I looking okay? I'm not entirely sure I'm liking this angle, but we'll see when I'm dressed. If I don't like it, I'll change things around. But I'm not moving my second monitor because I need it for other work. So I'm just gonna have to deal with what I've got. I might not be making videos or streaming as much in the coming months because of what I'm intending to do with my other work. Because I need to lock in and actually do something that will progress my career in the media industry. And I'm going to be honest, as much as I enjoy doing this channel, I don't think it's I don't think it's sustainable. So I will keep doing it, but maybe not as much because I want to do other things. I don't see myself as the next Finster or, you know. I mean, it'd be nice, but I don't think I'm ever going to transition. I like being a guy, I'll be honest. Lovely. Oh, I've just realised I didn't brush off the excess when I first put the powder on. Never mind. I don't think you can tell, can you? Can you? Ah, it's alright. It's fine. These lights aren't particularly great, but there you go. I am feeling a little bit drunk now. Are you still landing? I think you mistyped there. To do that, say it's on fitness. Yes, I have recorded a fitness video. Well, it's going to be I don't think it's going to be a series. I think it's going to be a one single video. I have it will be in guy mode, so it won't be. I might do like, you know, B-roll in girl mode, but the main bulk of the fitness stuff will be in guy mode. And I have filmed all of my training from starting fresh up until when I got the flu. So it's unfortunate that I got the flu because it means I haven't progressed as much as I wanted to, and I'm going to have to start from scratch as soon as my chest clears up. I can't train yet until my chest clears up, which is unfortunate. But I am going to be releasing the video on fitness maybe this month or maybe early next month. But it's going to be a lot of video editing because there's about 8 or 9 days worth of footage to get through. So it's basically me going from the very, very start, trying to figure out how much you can lift safely and with decent not posture. What am I thinking of? What's the word I'm thinking of? I don't know. I've lost it. Sod it. I'm just I give up. Not posture. What's the word I'm looking for? I don't know. I literally just don't know. I've missed some. I've kind of shaved my eyebrows earlier, and I've missed a bit. That's not good. Anyway, what was I talking about? So yeah, the fitness stuff. So basically, it's going to be, it's gonna like be a it's going to be one single video, but it's not going to be like 10 minutes long or 10 to 15 minutes long. It's going to be at least half an hour long. Okay, we've got 15 minutes before Jensen's on. And it's basically going to go through how you can start weight training as a beginner. Make sure you can lift with good form. Form, that's the word I'm looking for. Making sure you can lift with good form. And yeah, just that's interesting. I can't see the chat. There we go. There we go. So yeah, it's basically going to be about making sure you can lift with good form as a beginner. And it's going to take you through the entire workout routine as a upper body lower body split, including an arm day because I'm tall and I need a separate arm day. I've got stray hair there. What the hell? Nope, that didn't come out. Come on. Nope, I literally tore out every other hair except that one. There you go. Got you. So yeah, it's gonna be a good video. It's gonna be a good video for people that are actually wanting to get into fitness, especially at this time of year. And the idea is to get people into tracking their workouts and tracking their eating habits, because let's be honest, it's not really easy to eat well in this day and age. I mean, even I don't eat 5 pieces of fruit and veg a day, but it's all focused on building as much muscle as possible in as little work as possible, with good form and good technique. So, excuse me. I'm sure it'll help some people out there. But yeah, it will be really, really good for people that are beginners and people who are wanting to work out in the gym. And yeah, it'll be good. I can't wait to edit it now. I've got this new graphics card. Up next, nVidia CEO Jensen's live keynote. Can't wait for Jensen to talk nothing but AI for the next 2 hours and only 5 minutes of consumer graphics cards. We all know it's going to happen. Okay. Eyebrows relatively done. Looks okay, I think. So what I'm going to do is first thing I'm going to do is take my eyeshadow. Actually, I might just do some really basic black eyeshadow. It's probably a good idea, really, isn't it? So just really, really basic black eyeshadow, because I've not got any colour on. I've not got any colour in my outfit. It's all black and white, so there's no point putting colour in my eye makeup because it doesn't really match. So I'm just going to basically do some very simple, very basic, easy peasy, lemon squeezy eye makeup. That's really not even anything. Why do you keep typing Raymond and love hearts and all that crap? Stop. If you're going to type something interesting. Bitch. How's that? Yeah, I can't see in my hang on. Let me move this down here so I can actually see it. There we go. It's not bad. It's not bad. I like it. I like it a lot. Okay, just some very light powder on my lower lids here. There we go. Easy peasy. Easy peasy. Lemony squeezy. Okay. I'm okay. I'm not dying. I'm dying a bit. Ugh. Right, let's put some blush on. This L'Oreal, whatever it's called. Not that you're going to be able to see it with the wig on. I mean, I might as well not do that side because you're not going to be able to see it. But might as well, because otherwise it'll look weird. I mean, I look weird anyway, but there you go. There you go. Okay. How long we got? Where? I can't see. What time is it? I've got 9 minutes. 9 minutes. Oh god, that's not great, is it? It's a good job it's going to be covered with a wig. Oh, that's okay. Right, so let me just oh god. What's this? Not that one. Where's my gel one? I need the gel fucking piece of shit. Where is it? Where is it? Cock it. Right, let's do this. So oh god, this is useless. Useless. Where the hell is my gel one? What's that? Got it. I got it. Excellent. Oh yeah, that's much better. Much better. Yeah. Meh. Yeah. I kind of buggered up with that, but never mind. Never mind. Be alright. It'll be a. Can you tell I'm from Nottingham? Oh, that's not gone well, has it? Oh dear. Oh dear. Okay, that side's not too bad. It's this side that buggered up. There we go. Better, much better. Eyeliner is so hard to do, especially winged liner. It really is. Especially because I'm a slightly older guy. I'm not young anymore. I've got hooded eyelids, so it's not. Look at that. I mean, it's not as entirely easy as an older guy with hooded eyelids. Hmm. Right. This is okay. Don't watch this if you're squeamish. I'm doing the bottom of my eyelid, so if you have a look at my eyes now, see how it looks a bit weird there. It looks like it's just a line below my lid. This is how you fix it. And some people can't do this because, and I highly recommend a gel eyeliner for this. I also haven't put my mascara on yet. And mascara really does help with this kind of stuff. See that? See how dark it looks now compared to my eyes? But I mean, you basically putting it on the waterline between your eyelashes and your eye, and some people can't do that, and I understand that. But yeah, it is hard to do. It is really hard to do. But there you go. So mascara. This should complete the look. Apart from the lipstick, and I've got 5 minutes. Hopefully, I don't mess this up. I got this. Don't worry. I know I'm a bit quiet right now. I can't. I'm concentrating. Shit. Buggered up. You can't tell. Good. Do you use false eyelashes? I do have false eyelashes, but I don't use them very much because it's really difficult to apply. I prefer just using mascara, and the reason being, um, I have quite long eyelashes. So if I just use mascara, I don't necessarily need to mess about with false eyelashes. Also, false eyelashes can look really stupid. So there you go. I'm going to wait for that to dry and apply the lipstick. And then put the wig on. Hopefully I've got 2 minutes. Okay. How's that? Oh, that's okay. That'll do. And here's the reason why I went to get the paper towel. This is a must. You have to do this. There you go. Sorted. Okay. I'm just going to apply some. Hang on. Let's put this up here. There we go. Excellent. Right, I'm going to put the. nVidia thing on. There we go. There we go. Good. Let's see what bullshit Jensen has got for us this year, shall we? I'm just going to finish off the makeup while we're watching the thing. How's the audio? Is it all okay? Is it all good? Can you hear the how we're doing? I imagine there's a lot of people on YouTube and Twitch streaming the CES nVidia show right now, but if you're watching me right now, watching this, then you obviously like something different. So thank you for watching. Let's do this. Right, I'm gonna put the wig on. So I'm going to be using this blonde wig today. And I don't think I've done this too many times on stream, so this is one of the first times I do this. Oh. There we go. Excellent. That's all good. Lovely. And I'm already dressed. Sort of. There we go. It's all good. look at the footwear I'm using. Okay. I'm all good. I'm all good. God, look at this. Look at the fat on me. I've just. So annoying. Okay, I'm just gonna do this what most women do. There you go. You can't tell now, can you? Can't tell that I'm fat as fuck. Okay, Jensen, we're ready for you. Let's do it. You're late, you son of a bitch. It's 2 minutes past. Okay. I'm ready. I'm ready for you to talk about AI for 2 hours. Oh, hang on. Before I do that, if Jensen's going to wear a leather jacket with, you know, with the snake skin stuff, then so am I. Why not? Let's do it. There we go. There we go. Ugh. Eh. Jesus. Good. Good, good, good. Yes! This is way too small for me. Look how big my tits are. Look at that. Right. Okay. I'm ready. Ready for you, Jensen. Give me your AI babies. Doing good. This is actually like a snake skin. It's like a faux snake skin jacket, if you can tell, because it's a bit late. Come on, Jensen, you're late. What are you doing? God damn it. Okay, I was just checking my my feed there. Okay. Are we all good? Are we ready? My dude, you're supposed to be starting at 9 o'clock. It's 5 past. What are you doing? I'm gonna go to sleep if you don't get on stage soon. Come on. Wow. How do I look, by the way, while we're waiting for this nVidia stream? Do I look okay? Oh, Jesus. My skirt's a bit... There we go. How am I looking? Puffing up a bit there. There we go. That's I prefer my waist lower, you know. I do prefer it lower. You know what I think? I think I need more rum. I've got lipstick on my thing. Even though I sorry. Blimey. Okay, you're late, Jensen. You're goddamn late, son of a bitch. You're supposed to be on now. Where are you? Why are you late? Ooh, Jesus. You know what? Is that going to work? Put it behind there like that. No? There you go. There you go. That's my new graphics card. Why are you so late? Why are you 10 minutes late? Are you having are they having technical difficulties? Is that what is that why? You know what I'm going to do? I'm going to see what's going on. Oh, nVidia CES 2026 late. Let's see if they actually are late. Oh, there's a Reddit post here saying, for the first time in 5 years, nVidia will not announce any new GPUs at CES. What a surprise! What a surprise! Just went on stream and they already had something earlier. Was that it? No, I don't. No, that was the pre-show talk. Yeah, that was the pre-show talk. Ugh.
It's more than a cache ISO.
Oh, for God's sake.
January, the month of
Adverts, you know what I mean?
or of more nutrition, the tastiest way to keep your resolutions. With more protein, less sugar, and full of flavor. Start your year with.
Yeah, it's just late, isn't it? It's just late. It's just not good enough, nVidia. What are you doing, Jensen? You having a wank? What are you doing? Come on, pal. We're all waiting for you to disappoint us. Jesus Christ. Got some good music going on there. Get rid of this piece of crap. Got some good music going on. Oh. Has anyone got any questions or anything? Because they are currently 13 minutes late. Fuck it. Sorry, I am still quite ill. Oh, oh, oh! Oh, shit. Sorry. Yes! Finally! It's about goddamn time. Fashionably late. RTX Nova rendering. RTX Mega Geometry. Flight Simulator. I have never played Flight Simulator. Is it good? I've never played Black Myth Wukong either. I should give it a go. Fucking AI. Of course AI. Why would it not be? Physics. Didn't you get rid of physics and... Oh, I like that. Okay, I think I might be a bit too drunk to appreciate all this. Supersonic rescale. I'm not being funny, nVidia, but could you not have done this like 10 minutes ago? This is like clearly a pre-rendered video. You know what I mean? I like Flight Simulator. I've never played it. I mean, I do like realism. That's the thing. Because that's supposed to be fusion. Sorry. Okay, this is where I believe where AI could actually give some benefit is in the health business. Why does that Earth look weird? Okay, so we've got some kind of space station. A space station of officers. Oh no, okay, it's not a space station, it's just officers.
Welcome to the stage, nVidia founder and CEO, Jensen Huang.
Is he wearing a snakeskin jacket? Is he? Or crocodile skin jacket? Yeah, he is. There he is.
Hello,
matching.
Vegas.
We're matching.
Happy New Year! Welcome to CES. Well, we have about 15 keynotes worth of material to pack in here. I'm so happy to see all of you. You got 3,000 people in this auditorium. There's 2,000 people in a courtyard watching us. There's another 1,000 people apparently in the 4th floor where there were supposed to be NVIDIA show floors, all watching this keynote. And of course, millions around the world are going to be watching this. To kick off this
Including me.
Well, every 10 to 15 years, the computer industry resets. A new platform shift happens. From mainframe to PC, PC to internet, internet to cloud, cloud to mobile.
How long before it says
Each
AI?
time, the world of applications target a new platform. That's why it's called a platform shift. You write new applications for a new computer.
Is there a bingo card for
Except
this?
this time, there are 2 simultaneous platform shifts, in fact, happening at the same time. While we now move to AI,
There it
applications
is.
are going to be
It said
built
AI.
At first, people thought AIs are applications. And in fact, AIs are applications, but you're going to build applications on top of AIs. But in addition to that, how you run the software, how you develop the software fundamentally changed. The entire 5-layer stack of the computer industry is being reinvented. You no longer program the software, you train the software. You don't run it on CPUs, you run it on GPUs. And whereas applications were pre-recorded, pre-compiled, and run on your device, now applications understand the context and generate every single pixel, every single token, completely from scratch every single time. Computing has been fundamentally reshaped as a result of accelerated computing, as a result of artificial intelligence. Every single layer of that 5-layer cake is now being reinvented. Well, what that means is some $10 trillion or so of the last decade of computing is now being modernized to this new way of doing computing. What that means is hundreds of billions of dollars, a couple of $100 billion in VC funding each year is going into
Got a bingo card.
modernize and inventing this new world. And what it means is $100 trillion of industry, several percent of which is R&D budget, is shifting over to artificial intelligence. People ask, where is the money coming from? That's where the money is coming from. The modernization of AI to AI, the shifting of R&D budgets from classical methods to now artificial intelligence methods. Enormous amounts of investments coming into this industry, which explains why we're so busy. And this last year was no difference. This last year was incredible. This last year, there's a slide coming. This is what happens when you don't practice. It's the first keynote of the year. I hope it's your first keynote of the year. Otherwise, you have been pretty busy. This is our first keynote of the year. We're going to get the spider webs out. And so 2025
Did it
was
say
an
AI?
incredible year.
Leather jacket. That can go.
It seemed like everything was happening all at the same time, and in fact, it probably was. The first thing, of course, is scaling laws. In 2015,
As I said,
the first
where's the AI
language
one?
model that I thought was really going to make a difference, made a huge difference. It was called BERT. 2017, Transformers came. It wasn't until 5 years later.
Look at all this
2022,
AI
that
stuff on the
ChatGPT
thing.
moment happened, and it awakened the world to the possibilities of artificial intelligence. Something very important happened a year after that. The first O1 model from ChatGPT, the first reasoning model, completely revolutionary, invented this idea called test time scaling, which is a very commonsensical thing. Not only did we pre-train a model to learn, we post-train it with our reinforcement learning so that it could learn skills. And now we also have test time scaling, which is another way of saying thinking. You think in real time. Each one of these phases of artificial intelligence requires an enormous amount of compute. And the computing law continued to scale. Large language models continued to get better. Meanwhile, another breakthrough happened. And this breakthrough happened in 2024.
Yeah.
Agentic systems started to emerge. In 2025, it started to proliferate just about everywhere. Agentic models that have the ability to reason, look up information, do research, use tools, plan futures, simulate outcomes, all of a sudden started to solve very, very important problems. One of my favorite agentic models is called Cursor, which revolutionized the way we do software programming at NVIDIA. Agentic systems are going to really take off from here. Of course, there were other types of AI. We know that large language models isn't the only type of information. Wherever the universe has information, wherever the universe has structure, we could teach a large language model, a form of language model, to go understand that information, to understand its representation, and to turn that into an AI. One of the biggest, most important one is physical AI. AIs that understand the laws of nature.
Physical AI.
Course,
What the fuck are you
physical
talking
AI
about?
is about AIs interacting with the world, but the world itself has information, encoded information, and that's called AI physics. AI that, in the case of physical AI, you have AI that interacts with the physical world, and you have AI physics, AI that understands the laws of physics. And then lastly, one of the most important things that happened last year, the advancement of open models. We can now know that AI is going to proliferate everywhere when open source, when open innovation, when innovation across every single company and every industry around the world is activated at the same time. Open models really took off last year. In fact, last year, we saw the advance of DeepSeek R1, the first open model that's a reasoning system. It caught the world by surprise, and it activated literally...
Is anyone else surprised that I got the idea right about him talking about AI for the whole 2 hours? Anyone?
All different kinds, and we now know that open models have also reached the frontier. Still solidly is 6 months behind the frontier models, but every single 6 months, a new model is emerging, and these models are getting smarter and smarter. Because of that, you could see the number of downloads has exploded. The number of downloads is growing so fast because startups want to participate in the AI revolution. Large companies want to, researchers want to, students want to, just about every single country wants to. How is it possible that intelligence, the digital form of intelligence, will leave anyone behind? And so open models has really revolutionized artificial intelligence last year. This entire industry...
You know what's crazy?
As a result of it. Now,
This is happening now.
Some time ago. You might have heard
Crazy.
that several years ago, we just started to build and operate our own AI supercomputers. We call them DGX clouds. A lot of people asked, are you going into the cloud business? The answer is no. We're building these DGX supercomputers for our own use. Well, it turns out we have billions of dollars of supercomputers in operation so that we could develop our open models. I am so pleased with the work that we're doing.
I bet you
It
are.
is starting to attract attention all over the world and all over the industries because we are doing frontier AI model work in so many different domains.
Yep.
The work that we did in proteins, in digital biology, La Proteina, to be able to synthesize and generate proteins, OpenFold 3 to understand the structure of proteins, Evo 2, how to understand and generate multiple proteins, otherwise the beginnings of cellular...
Do you remember when
representation.
NVIDIA was just a
Earth 2,
GPU
AI that
manufacturer?
understands the laws of
Do you remember that?
The work that we did with
Do you remember?
FastNet, the work
They
that we
were
did
they were
with
good
Coordinates
days.
really revolutionized the way that people are doing weather prediction. Nemotron, we're now doing groundbreaking work there. The first hybrid transformer SSM model that's incredibly fast and therefore can think for a very long time or can think very quickly for not a very long time and produce very, very smart, intelligent answers. Nemotron 3 is groundbreaking work, and you can expect us to deliver other versions of Nemotron 3 in the near future. Cosmos, a frontier, open, world foundation model, one that understands how the world works. Groot, a humanoid robotic system, articulation, mobility, locomotion. These models, these technologies are now being integrated, and in each one of these cases, open to the world. Frontier humanoid robotics models open to the world. And
Robotics.
Then today, we're going to talk a little bit about Alpamayo, the work that we've been doing in self-driving cars. Not only do we open source the models, we also open source the data that we use to train those models. Because in that way, only in that way, can you truly trust how the models came to be. We open source all the models. We help you make derivatives from them. We have a whole suite of libraries. We call the NEMO libraries, physics NEMO libraries, and the Clara NEMO libraries, each bio-NEMO libraries. Each one of these libraries are life cycle management systems of AIs, so that you could process the data, you could generate data, you could train the model, you could create the model, evaluate the model, guardrail the model, all the way to deploying the model. Each one of these libraries are incredibly complex, and all of it is open source. And so now, on top of this platform, nVidia is a frontier AI model builder. And we build it in a very special way. We build it completely in the open so that we can enable every company,
it's nothing but
industry,
AI.
every country to be part of this AI revolution. I'm incredibly proud of the work that we're doing there. In fact, if you notice the charts, the chart shows that our contribution to this industry is bar none.
You've
And you
shown
can
this
see us, in
chart
fact, continue
3,
that
4
if you want
times
to.
already. Crack on.
These models are also world-class. All systems are down. This never happens in Santa Clara. Is it because of Las Vegas? Somebody must have won a jackpot outside. All systems are down. Okay, I think my system's still down, but that's okay. I'll make it up as I go. And so not only are these models frontier capable, not only are they open, they're also top the leaderboards. This is an area where we're very proud. They top leaderboards in intelligence. We have,
Oh my God, this is all
understand
bullshit.
multi-modality documents, otherwise known as PDFs. The most valuable content in the world are captured in PDFs. But it takes artificial intelligence to find out what's inside, interpret what's inside, and help you read it. And so our PDF retrievers, our PDF parsers are world-class. Our speech recognition models, absolutely world-class. Our retrieval models, basically search,
Got any world-class things in there?
search, AI search, the database engine of the modern
I mean,
AI era,
we can tick off
world-class.
gibberish
So we're
buzzword string,
on top
right?
of leaderboards
That's
constantly.
definitely
This
been
is an
done.
area we're very proud of. And all of that is in service of your ability to build AI agents. This is really a groundbreaking area of development. You know, at first when ChatGPT came out, people said, you know, gosh, it produced really interesting results, but it hallucinated greatly. And the reason why it hallucinated, of course, it could memorize everything in the past, but it can't memorize everything in the future, in the current. And so it needs to be grounded.
I'm sorry, it can't memorize everything in the future. What the fuck are you talking about, Jensen?
Answers a question. The ability to reason about, do I have to do research? Do I have to use tools? How do I break up a problem into steps? Each one of these steps, something that the AI model knows how to do, and together it is able to compose it into a sequence of steps to perform something it's never done before, never been trained to do. This is the wonderful capability of reasoning. We can encounter a circumstance.
You are
we've
so
never seen
beautiful,
before,
gorgeous goddess.
and break
Thank
it
you.
down into
Yes, I am.
circumstances and knowledge or rules that we know how to do because we've experienced it in the past. And so the ability for AI models now to be able to reason, incredibly powerful. The reasoning capability of agents opened the doors to all of these different applications. We no longer have to train an AI model to know everything on day one. Just as we don't have to know everything on day one. That we should be able to...
This is just crack on, will ya? Jesus.
Large language models has now made this fundamental.
Okay, I'm just going to mute this a second. No, I'm not. What I don't want to happen in this keynote speech is for them to announce the super editions of the RTX 50 series cards. I've just bought that, the 5070 Ti. I wanted to buy the 5070 Ti Super. I don't want them to announce the Super Series.
And the first time I realized they were using multiple models at the same time, I thought it was completely genius. Of course we would do that. Of course an AI would also call upon all of the world's great AIs to solve the problem it wants to solve at any part of the reasoning chain. And this is the reason why AIs are really multimodal, meaning they understand speech and images,
hello.
text and videos and 3D graphics and proteins. It's multimodal. It's also multi-model, meaning that they should be able to use any model that best fits the task. It is multi-cloud by definition, therefore, because these AI models are sitting in all these different places, and it also is hybrid cloud. Because if you're an enterprise company or you built a robot or whatever that device is, sometimes it's at the edge, sometimes the radio cell tower, maybe sometimes it's in an enterprise, or maybe it's a place a hospital where you need to have the data in real time right next to you. Whatever those applications are, we know now this is what an AI application looks like in the future. Or another way to think about that, because future applications are built on AIs.
This is all bullshit. We want to know what you're releasing and when. We don't care about all this bullshit you're talking about.
Agentic AIs that could do the things that I'm talking about, that is multi-model, has now turbocharged AI startups of all kinds. And now you can also, because of all of the open models and all the tools that we provided you, you could also customize your AIs to teach your AI skills that nobody else is teaching. Nobody else is causing their AI to become intelligent or smart in that way. You could do it for yourself. And that's the work that we do with Nemotron, Nemo, and all of the things that we do with open models is intended to do. You put a smart router in front of it, and that router is essentially a manager that decides which one of the tasks, based on the intention of the prompts that you give it, which one of the models
what the
is
hell
best
just
fit
happened?
for that application, for that solving that problem.
What the hell?
Okay? So now, when you think about this
What's happened to my lighting?
what do you have? When you think about this architecture, all of a sudden you have an AI that's on the one hand, completely customizable by you. Something that you could teach to do your own very skills for your company. Something that's domain secret. Something where you have deep domain expertise. Maybe you've got all of the data that you need.
What the hell's going on?
On the other hand,
why is my lighting fucked up?
Is always at the frontier.
Shit.
By definition. You're always at the frontier on the one hand. You're always customized on the other hand, and it should just run. And so we thought
what's happened to my lighting?
The simplest of examples to make it available to you. This entire framework we call a blueprint.
What's going on?
That are integrated into enterprise SaaS platforms all over the world, and we're really pleased with the progress. But what we do is show you a short example of something that anybody can do.
What the fuck?
Let's build a personal assistant.
I don't know what's happened with my lighting. I genuinely don't.
And even keep an eye on my home. I use Brev to turn my DGX Spark into a personal cloud. So I can use the same interface whether I'm using a cloud GPU or a DGX Spark. I use a Frontier Model API to easily get started. I wanted to help me with my emails, so I create an email tool for my agent to call. I want my emails to stay private, so I'll add an open model that's running locally on the Spark. Now for any job, I want the agent to use the right model for the right task, so I'll use an intent-based model router. This way, prompts that need email will stay on my Spark, and everything else can call the Frontier model.
What is going on with my lighting?
Interact with my world, so I'll hook it up to Hugging Face's Reachy mini robot.
Let me just see if I can fix it.
My agent controls the head, ears, and camera of the Reachy with tool calls. I want to give Reachy a voice, and I really like 11 Labs, so I'll hook up their API.
Hi, I'm Reachy, running on DGX Spark.
Hey Reachy, what's on my to-do list today?
Your to-do list today. Grab groceries, eggs, milk, butter, and send Jensen the new script.
Okay, let's send Jensen that update. Tell him we'll have it for him by the end of the day.
Will do.
Reachy, there's a sketch too. Can you turn it into an architectural rendering?
Sure.
I don't know what's going on with my lighting.
Nice. Now make a video and show me around the room.
What the hell's going on?
Here you go.
That's great. With Brev, I can share access to my Spark and Ricci, so I'm going to share it with Anna.
Hey Ricci, what's Potato up to?
God damn it. I'm having problems
He's on the
here.
couch. I remember you don't like this. I'll tell him to get off. Potato, off the couch.
With all the progress in open source, it's incredible to see what you can build. I'd love to see what you create.
Isn't that incredible? Now, the amazing thing is, that is utterly trivial now. That is utterly trivial now. And yet, just a couple of years ago, all of that would have been impossible. Absolutely unimaginable. Well, this basic framework, this basic way of building applications, using language models.
Why have my lights gone weird?
Using language models. Using language models that are pre-trained and they're proprietary, they're frontier. Combine it with customized language models into a agentic framework, a reasoning framework that allows you to access tools and files.
Okay, hang on.
And maybe even connect.
I'm gonna fix this.
This is basically the architecture of AI applications or applications in the modern age. And the ability for us to create these applications are incredibly fast. And notice, if you give it this application information that it's never seen before, or in a structure that is not represented
I don't know what's going on.
exactly as you thought, it can still reason through it and make its best effort to reason through the data, the information, to try to understand how to solve the problem. Artificial intelligence. Okay, so this basic framework is now being integrated, and everything that I just described, we have the benefit of working with some of the world's leading enterprise platform companies. Palantir, for example, their entire AI and data processing platform is being integrated and accelerated by nVidia today. ServiceNow, the world's leading customer service and employee service platform. Snowflake, the world's top data platform in the cloud. Incredible work that is being done.
Damn it.
CodeRabbit, we're using CodeRabbit all over NVIDIA. CrowdStrike, creating AIs to detect.
I don't know what's going on with my
AI threats.
lights.
NetApp, their data platform now has NVIDIA's semantic AI on top of it and agentic systems on top of it for them to do customer service. But the important thing is this. Not only is this the way that you develop applications now, this is going to be the user interface of your platform. So whether it's Palantir or ServiceNow or Snowflake and many other companies that we're working with, the agentic system is the interface. It's no longer Excel with a bunch of squares that you enter information into. Maybe it's no longer just command line. All of that multimodality information is now possible, and the way you interact with your platform is much more, well, if you will, simple, like you're interacting with people. And so that's enterprise AI being revolutionized by agentic systems. The next thing is physical AI. This is an area that you've seen me talk about for several years. In fact, we've been working on this for 8 years.
I'm trying to figure out this fucking lighting situation.
That is intelligent inside a computer and interacts with you with screens and speakers to something that can interact with the world, meaning it can understand the common sense of how the world works. Object permanence. If I look away and I look back, that object is still there. Causality. If I push it, it tips over. It understands friction and gravity. It understands inertia. That a heavy truck rolling down the road is going to need a little bit more time to stop. That a ball is going to keep on rolling. These ideas are common sense to even a little child, but for AI, it's completely unknown. And so we have to create a system that allows AIs to learn the common sense of the physical world, learn its laws, but also to be able to, of course, learn from data, and the data is quite scarce, and to be able to evaluate whether that AI is working, meaning it has to simulate in an environment. How does an AI know that the actions that it's performing is consistent with what it should do, if it doesn't have the ability to simulate the response of the physical world back on its actions. The response of its actions is really important to simulate. Otherwise, there's no way to evaluate it. It's different every time. And so this basic system requires 3 computers. One computer, of course, the one that we know that NVIDIA builds for training the AI models. Another computer that we know is to inference the models. Inferencing the model is essentially a robotics computer that runs in a car or runs in a robot.
This is
runs in
annoying
a
me a
factory,
little bit.
Runs anywhere at the edge. But there has to be another computer that's designed for simulation. And simulation is at the heart of almost everything NVIDIA does. This is where we are most comfortable. And simulation was really the foundations of almost everything that we've done with physical AI. So we have 3 computers and multiple stacks that run on these computers, these libraries, to make them useful. Omniverse is our digital twin, physically based simulation world. Cosmos, as I mentioned earlier, is our foundation model, not a foundation model for language, but a foundation model of the world. And is also aligned with language. You could say something like, what's happening to the ball? And they'll tell you the ball's rolling down the street. And so a world foundation model, and then of course the robotics models. We have 2 of them. One of them is called Groot. The other one's called Alpamayo that I'm going to tell you about. Now, one of the most important things that we have to do with physical AI is to create the data to train the AI in the first place. Where does that data come from? Rather than, instead of having languages, because we created a bunch of text that are what we consider ground truth that the AI can learn from, how do we teach an AI the ground truth of physics? There are lots and lots of videos, but hardly enough to capture the diversity and the type of interactions that we need. And so this is where great minds came together and transformed.
God damn it. Just bear with me a second.
What used to be compute into data. Now, using synthetic data generation that is grounded and conditioned by the laws of physics, grounded and conditioned by ground truth, we can now selectively, cleverly generate data that we can then use to train the AI. So for example, what comes into this AI, this Cosmos AI world model on the left, over here, is the output of a traffic simulator. Now this traffic simulator is hardly enough for an AI to learn from. We can take this, put it into a Cosmos foundation model, and generate surround video that is physically based and physically plausible that the AI can now learn from. And there are so many examples of this. Let me show you what Cosmos can do.
What is going on? It's pissed me off.
The ChatGPT moment for physical AI is nearly here.
Fucking
but the challenge is clear.
I literally said they were going to talk about AI for 2 fucking hours.
Collecting real-world training data is slow and costly, and it's never enough. The answer is synthetic data. It starts with NVIDIA Cosmos, an open, frontier world foundation model for physical AI. Pre-trained on internet-scale video, real driving and robotics data, and 3D simulation. Cosmos learned a unified representation of the world, able to align language, images, 3D, and action. It performs physical AI skills like generation, reasoning, and trajectory prediction. From a single image, Cosmos generates realistic video. From 3D scene descriptions, physically coherent motion. From driving telemetry and sensor logs, surround video. From planning simulators, multi-camera environments. Or from scenario prompts, it brings edge cases to life. Developers can run interactive closed-loop simulations in Cosmos. When actions are made, the world responds. Cosmos reasons. It analyzes edge scenarios, breaks them down into familiar physical interactions, and reasons about what could happen next. Cosmos turns compute into data, training AVs for the long tail, and robots how to adapt for every scenario.
Like, I literally can't turn this fucking lighting back on.
I know, it's incredible. Cosmos is the world's leading foundation model, world foundation model. It's been downloaded millions of times, used all over the world, getting the world ready for this new era of physical AI. We use it ourselves as well. We use it ourselves to create our self-driving car, using it for scenario generation and using it for evaluation. We could have something that allows us to effectively travel billions, trillions of miles, but doing it inside a computer. And we've made enormous progress. Today, we're announcing Alpamayo, the world's first thinking, reasoning, autonomous vehicle AI. Alpamayo is trained...
Nobody gives a shit about a fucking thinking car. Jesus Christ.
The camera in, lots and lots of miles that are driven by itself, where we human drive it, using human demonstration. And we have lots and lots of miles that are generated by Cosmos.
Okay.
In addition to that, hundreds of thousands of examples are labeled very, very carefully so that we could teach the car how to drive. Alpamayo does something that's really special. Not only does it take sensor input and activates steering wheel, brakes, and acceleration, it also reasons about what action it is about to take. It tells you what action it's going to take, the reasons by which it came about that action, and then, of course, the trajectory. All of these are coupled directly and trained very specifically by a large combination of human-trained and as well as Cosmos-generated data. The result of it is just really incredible. Not only does your car drive as you would expect it to drive, and it drives so naturally because it learned directly from human demonstrators, but in every single scenario, when it comes up to the scenario, it reasons about, it tells you what it's going to do, and it reasons about what's about to do. Now, the reason why this is so important is because of the long tail of driving. It's impossible for us to simply collect every single possible scenario for everything that could ever happen in every single country, in every single circumstance that's possibly ever going to happen for all the population.
I can't sort this fucking lighting thing out.
It is very likely that every scenario, if decomposed into a whole bunch of other smaller scenarios, are quite normal for you to understand. And so these long tails will be decomposed into quite normal circumstances that the car knows how to deal with. It just needs to reason about it. And so let's take a look. Everything you're about to see is one shot. It's no hands.
Routing to your destination. Buckle up.
God damn it. No one... Does anybody care about AI fucking cars? Seriously. Okay, I'm going to change these lighting things around because it's pissing me off. Ugh. This might not go too well. I think we're good. There we go. Goddamn useless piece of shit. Can you still hear me? Yes, you can. Good. So we're just going to be watching some... So nVidia is getting into automated AI fucking cars. Really? Like, I mean, what's the point in driving? I absolutely love driving. You will never get me to buy a car that has AI driving assisted, like, just stupid. It's stupid.
You have arrived.
Oh, hello. Hi.
We started working on
AI driving.
For that is because we reasoned early on that deep learning and artificial intelligence was going to reinvent the entire computing stack. And if we were ever going to understand how to navigate ourselves and how to guide the industry towards this new future, we have to get good at building the entire stack. Well, as I mentioned earlier, AI is a 5-layer cake. The lowest layer is land, power, and shell. In the case of robotics, the lowest layer is the car. The next layer above it is chips. GPUs, networking chips, CPUs, all that kind of stuff. The next layer above that is the infrastructure. That infrastructure, in this particular case, as I mentioned with physical AI, is Omniverse and Cosmos. And then above that are the models. And in the case of the models above that I've just shown you, the model here is called AlphaMayo. And AlphaMayo today is open sourced. This incredible body of work, it took several thousand people. Our AV team is several thousand people, just to put in perspective. Our partner, Ola, I think Ola's here in the audience somewhere.
The thing is, Jensen, people love driving. Why would you take that away from them by using AI to drive for them? It's ridiculous.
1 billion cars on the road will all be autonomous. You could either have it be a robot.
I never ever want an autonomous, fuck it. I never want an AI vehicle.
Or you could decide to drive for yourself. And so, but every single car will have autonomous vehicle capability. Every single car will be AI powered. And so the model layer in this case is AlphaMayo, and the application above that is the Mercedes-Benz. Okay, and so this
fucking Mercedes
entire stack.
Mercedes is shit anyway. I know so many people that have Mercedes, and Mercedes constantly break down.
The first AV car from nVidia is going to be on the road in Q1, and then it goes Europe in Q2, here in the United States in Q1, then Europe in Q2, and I think it's Asia in Q3 and Q4. And the powerful thing is that we're going to keep on updating it with next versions of AlphaMayo and versions after that. There's no question in my mind now that this is going to be one of the largest robotics industries, and I'm so happy that we worked on it. And it taught us an enormous amount about how to help the rest of the world build robotic systems. That deep understanding and knowing how to build it ourselves, building the entire infrastructure ourselves, and knowing what kind of chips a robotic system would need. In this particular case, dual Orins, the next generation dual Thors. These processors are designed for robotic systems and was designed for the highest level of safety capability. This car just got rated. It just went to production. The Mercedes-Benz CLA was just rated by NCAP, the world's safest car.
Blah, blah, blah.
It is the only system that I know that has every single line of code, the chip, the system, every line of code, safety certified. The entire model system is based on sensors are diverse and redundant, and so is the self-driving car stack. The AlphaMayo stack is trained end-to-end and has incredible skills. However, Nobody knows until you drive it forever that it's going to be perfectly safe. And so the way we guardrail that is with another software stack, an entire AV stack underneath. That entire AV stack is built to be fully traceable. And it's taken us some 5 years to build, 6, 7 years actually, to build that second stack. These two software stacks are mirroring each other, and then we have a policy and safety evaluator decide, is this something that I'm very confident and can reason about driving very safely? If so, I'm going to have Alpamayo do it. If it's a circumstance that I'm not very confident in, and the safety policy evaluator decide that we're going to go back to a simpler, safer guardrail system, then it goes back to the classical AV stack. We're the only car in the world with both of these AV stacks running, and all safety systems should have diversity and redundancy. Well, our vision is that someday, every single car, every single truck will be autonomous. And we've been working towards that future.
I'm bored. I'm going for a piss.
Is vertically integrated, of course, in the case of Mercedes-Benz. We built the entire stack together. We're going to deploy the car. We're going to operate the stack. We're going to maintain the stack for as long as we shall live. However, like everything else we do as a company, we build the entire stack, but the entire stack is open for the ecosystem. And the ecosystem working with us to build L4 and robo-taxis is expanding, and it's going everywhere. I fully expect this to be, well, this is already a giant business for us. It's a giant business for us because they use it for training data, processing data, and training their models. They use it for synthetic data generation in some cases. In some companies, they pretty much just build the computers, the chips that are inside the car. And some companies work with us full stack. Some companies work with us some partial part of that. Okay, so it doesn't matter how much you decide to use. You know, my only request is use a little bit of NVIDIA wherever you can, and you know, but the entire thing is open. Now, this is going to be the first large-scale mainstream AI, physical AI market, and this is now, I think we can all agree, fully here. And this inflection point of going from not autonomous vehicles to autonomous vehicles is probably happening right about this time. In the next 10 years, I'm fairly certain a very, very large percentage of the world's cars will be autonomous or highly autonomous. But this basic technique that I just described in using the 3 computers, using synthetic data generation and simulation, applies to every form of robotic systems. It could be a robot that is just an articulator, a manipulator.
Oh, it's talking about robots now.
Robot.
Jesus
Maybe
Christ.
It's a full humanoid robot. And so the next journey, the next era for robotic systems is going to be, you know, robots. And these robots are going to come in all kinds of different sizes. And I invited some friends. Did they come?
Oh! Robotic show. Here we go. Robotic show. There we go. Hey. Got a robotic show there.
Come on. Hurry. Did you tell R2-D2 you're going to be here? Did you? And C-3PO? Okay. All right. Come here. Now, one of the things that's really, you have Jetsons. They have little Jetson computers inside them. They're trained inside Omniverse. And how about this? Let's show everybody the simulator that you guys learned how to be robots in. You guys want to look at that? Okay, let's look at that. Run it, please.
I'm hungry. I'm going to go get something to eat. I'll be back in a second while this bullshit's going on.
Isn't that amazing? That's how you learn to be a robot. You did it all inside Omniverse. And the robot simulator is called Isaac. Isaac Sim and Isaac Lab. And anybody who wants to build a robot, you know, nobody's going to be as cute as you. But now we have look at all these friends that we have building robots. We're building big ones. No, like I said, nobody's as cute as you guys are. But we have Neurobot and we have Agibot over there. You know, we have LG over here. They just announced a new robot. Caterpillar, they've got the largest robots ever. That one delivers food to your house. That's connected to Uber Eats, and that's Surf Robot. I love those guys. Agility, Boston Dynamics, incredible. You got surgical robots. You got manipulator robots from.
Okay, so I've got a my protein pudding
universal robotics
and
robot,
a
incredible number
Huel.
of different robots. And so this is the next chapter. We're going to talk a lot more about robotics in the future, but it's not just about the robots. In the end, I know everything's about you guys. It's about getting there. And one of the most important industries in the world that will be revolutionized by physical AI and AI physics is the industry that started all of us. At nVidia, it wouldn't be possible if not for the companies that I'm about to talk to. And I'm so happy that all of them, starting with Cadence, is going to accelerate everything Cadence. CUDA-X integrated into all of their simulations and solvers.
Is that a bingo card?
nVidia physical AI
Is
that
it?
they're going to use for different physical plants and plant simulations. You got AI physics being integrated into these systems. So whether it's an EDA or SDA, and in the future robotic systems, we're going to have basically the same technology that made you guys possible. Now completely revolutionize these design stacks. Synopsys. Without Synopsys, you know, Synopsys and Cadence are completely indispensable in the world of chip design. Synopsys leads in logic design and IP. In the case of Cadence, they lead physical design, the place and route, and emulation and verification. Cadence is incredible at emulation and verification. Both of them are moving into the world of system design and system simulation.
They're real robots. They don't look real to me.
We're going to design your chips inside Cadence and inside Synopsys. We're going to design your systems and emulate the whole thing and simulate everything inside these tools. That's your future. We're going to you're going to be born inside these platforms. Pretty amazing, right? And so we're so happy that we're working with these industries. Just
so cute.
We've integrated NVIDIA into Palantir and ServiceNow. We're integrating NVIDIA into the most computationally intensive simulation industries, Synopsys and Cadence. And today we're announcing that Siemens is also doing the same thing. We're going to integrate CUDA-X, physical AI, agentic AI, NeMo, Nemotron, deeply integrated into the world of Siemens. And the reason for that is this. First, we designed the chips, and all of it in the future will be accelerated by NVIDIA. You're going to be very happy about that. We're going to have agentic chip designers and system designers working with us, helping us do design, just as we have agentic software engineers helping our software engineers code today. And so we'll have agentic chip designers and system designers. We're going to create you inside this. But then we have to build you. We have to build the plants, the factories that manufacture you. We have to design the manufacturing lines that assemble all of you. And these manufacturing plants are going to be essentially gigantic robots.
You know what these robots remind me of?
Isn't that right? I know.
Wall-E.
So you're going to be
You ever seen
designed in a
Wall-E?
computer. You're going to be made in a computer. You're going to be tested and evaluated in a computer long before you have to spend any time dealing with gravity. I know. Do you know how to deal with gravity? Can you jump?
Kind of cute.
Can you jump? Okay, all right, don't show off. Okay, so now the industry that made NVIDIA possible I'm just so happy that now the technology that we're creating is at a level of sophistication and capability that we can now help them revolutionize their industry. And so what started with them, we now have the opportunity to go back and help them revolutionize theirs. Let's take a look at the stuff that we're going to do with Siemens. Come on.
Breakthroughs in physical AI are letting AI
Fucking, it's
move
nothing
from
but
screens
AI.
to our
I can't
physical
believe
world.
how right I was that they're just going to
Just
talk
in
about
time,
AI for
as the
2
world
hours.
builds factories of every kind for chips, computers, life-saving drugs, and AI. As the global labor shortage worsens, we need automation powered by physical AI and robotics.
Not a
more
labour
than
shortage, is it?
ever. This, where AI meets the world's largest physical industries, is the foundation of nVidia and Siemens partnership. For nearly 2 centuries, Siemens has
bit
built
drunk.
the world's industries. And now, it is reinventing it for the age of AI. Siemens is integrating nVidia CUDA-X libraries, AI models, and Omniverse into its portfolio of EDA, CAE, and digital twin tools and platforms.
Fucking jargon.
Together, we're
Absolute
bringing
bullshit
physical
jargon.
AI
Have I
to
already...
the full industrial life cycle. From design and simulation to production and operations. We stand at the beginning of a new industrial revolution, the age of physical AI, built by nVidia and Siemens for the next age of industries.
Incredible, right, guys? What do you think? All right, I'll hang on tight. Just hang on tight. And so this is, if you look at the world's models, there's no question OpenAI is the leading.
Why are you showing this slide again? Come
more
on.
OpenAI tokens are generated than just about anything else. The second largest group, is probably open models.
I want those little robots to rebel and just go rogue.
So many different types of domains and modalities.
That would be amazing.
Models will be by far the largest. Let's talk about somebody really special. You guys want to do that? Let's talk about Vera Rubin. Vera Rubin, yeah, go ahead. She's an American astronomer. She was the first to observe. She noticed that the tails of the galaxies were moving about as fast as the center of the galaxies. Well, I know, it makes no sense. It makes no sense. Newtonian physics would say, just like the solar system, the planets further away from the sun is circling the sun slower than the planets closer to the sun. And therefore, it makes no sense that this happens unless there's invisible bodies, we call them, she discovered dark matter, that occupy space even though we don't see it. And so Vera Rubin is the person that we named our next computer after. Isn't that a good idea? I know.
Yeah.
Okay, Vera Rubin is designed to address this fundamental challenge that we have. The amount of computation necessary.
Insane demand for AI computing.
The demand
Fuck
for
off,
NVIDIA
nVidia.
GPUs is skyrocketing. It's skyrocketing because models are increasing.
You are ruining
an order of a magnitude every single year.
consumer gaming
not to mention,
and
as I mentioned,
consumer...
O1's introduction was an inflection point for AI. Instead of a one-shot answer, inference is now a thinking process. And in order to teach the AI how to think, reinforcement learning and very significant computation was introduced into post-training.
I am absolutely sick and tired of them talking about AI.
Otherwise known as imitation learning or supervision training. You now
Have you not got
reinforcement
anything
learning,
else to talk
essentially
about
the computer
other than AI?
trying different iterations itself, learning how to perform a task. The amount of computation for pre-training, for post-training, for test time scaling has exploded as a result of that. And now, every single inference that we do, instead of just one shot, the number of tokens, you could just see the AIs think, which we appreciate. The longer it thinks, oftentimes it produces a better answer. And so test time scaling causes the number of tokens to be generated increase by 5x every single year. Not to mention, meanwhile, the race is on for AI. Everybody's trying to get to the next level. Everybody's trying to get to the
The
next
race
frontier.
is not on
And
for
every time they
AI.
get
You're
to the
just
next frontier,
manufacturing it
the
yourselves.
last generation AI tokens.
Nobody cares about AI. You're just manufacturing it yourselves,
factor of
and it's
10x
all
every year.
gonna.
The
It's a
10x
bubble.
decline every
It's
year
gonna
is actually
disappear.
telling you something different. It's saying that the race is so intense. Everybody's trying to get to the next level, and somebody is getting to the next level. And so therefore, all of it is a computing problem. The faster you compute, the sooner you can get to the next level of the next frontier. All of these things are simultaneously happening at the same time. And so we
Oh,
decide
hello.
that we have to advance the state of the art of computation every single year, not 1 year left behind. And now we've been shipping GB200s a year and a half ago. Right now we're in full-scale manufacturing of GB300.
Yeah.
And if Vera Rubin is going to be in time for this year, it must be in production by now. And so today I can tell you that Vera Rubin is in full production.
What does that even mean? No, what?
You guys want to take a look at Vera Rubin? All right, come on. Play it, please.
Nobody knows
Vera
what that
Rubin
means.
Arrives just in time for the next frontier of AI.
Fucking
This is the story of
AI.
how we built it. The architecture, a system of 6 chips, engineered to work as one, born from extreme co-design. It begins with Vera, a custom-designed CPU, double the performance of the previous generation. And the Rubin
Fuck's
GPU.
sake.
Vera and Rubin are co-designed.
Why
from the
can't you
start
fucking-
to bidirectionally and coherently share data faster and with lower latency?
Did I just say Blackwell?
Then,
So it's the same. It's the
17,000
same
components come
generation.
together on a Vera Rubin compute board.
It's the same generation.
High-speed robots place components with micron precision before the Vera CPU and 2 Rubin GPUs complete the assembly. Capable of delivering 100 petaflops of AI, 5 times that of its predecessor. AI needs data, fast. Connect X9 delivers 1.6 terabits per second of scale-out bandwidth to each GPU. Bluefield 4 DPU offloads storage and security, so compute stays fully focused on AI. The Vera Rubin compute tray, completely redesigned with no cables, hoses, or fans, featuring a Bluefield 4 DPU, 8 Connect X9 NICs, 2 Vera CPUs, and 4 Rubin GPUs. The compute building block of the Vera Rubin AI supercomputer.
I mean,
Next, the 6th generation NVLink switch. Moving more data than the global internet, connecting 18 compute nodes, scaling up to 72 Rubin GPUs, operating as one. Then, Spectrum X Ethernet Photonics. The world's first Ethernet switch with 512 lanes and 200 gigabit capable co-packaged optics scale out thousands of racks into an AI factory.
it's nothing but
engineers
AI.
since
We've been
design
watching this for over an hour and 20
Vera
minutes,
Rubin
nearly,
NVL72
and over.
comes online.
It's been nearly an hour and 20 minutes, and they've talked
18
nothing except
9
for fucking
NVLink
AI.
switch trays,
It's ridiculous.
20 trillion transistors, weighing nearly 2 tons.
I can't wait till the AI bubble
One giant
bursts.
leap
I
to the
really
next
can't.
frontier of AI.
Fucking ridiculous.
Rubin is here.
An hour and 20 minutes of nothing
What do you
but
guys
talking
think?
about AI. Come on, nVidia.
This is a Rubin pod, 1,152 GPUs in 16 racks. Each one of the racks, as you know, has 72 Vera Rubin, or 72 Rubins. Each one of the Rubins is 2 actual GPU dies connected together. I'm going to show it to you. But there are several things that, well, I'll tell you later. I can't tell you everything right away.
Why can't you tell me everything right
We
away?
designed 6 different chips. First of all, we have a rule inside our company, and it's a good rule. No new generation should have more than 1 or 2 chips change. But the problem is this. As you could see, we were describing the total number of transistors in each one of the chips that were being described, and we know that Moore's law has largely slowed. And so the number of transistors we can get year after year after year can't possibly keep up with the 10 times larger models. It can't possibly keep up with 5 times per year more tokens generated. It can't possibly keep up with the fact that cost decline of the tokens are going to be so aggressive. It is impossible to keep up with those kind of rates. If
God, the
industry-
bullshit
if the
jargon
industry
that's going on
continues
right
to
now is
advance,
ridiculous.
unless
Is there a jargon thing?
we deployed aggressive,
Shit.
extreme
What the fuck have I
co-design,
just done?
basically innovating across all of the chips, across the entire stack, all at the same time, which is the reason why we decided that this generation, we had no choice but to design every chip over again. Now, every single chip that we were describing just now can be a press conference in all in itself.
I'm gonna
And
get
there's
rid
an
of that
entire
one, 'cause
company
that's-
who's probably dedicated to doing that back in the old days.
Oh, hello.
Each one of them are completely revolutionary and the best of its kind. The Vera CPU, I'm so proud of it. In a power-constrained world, Grace CPU is 2 times the performance. In a power-constrained world, it's twice the performance per watt of the world's most advanced CPUs.
Right.
Its data rate is insane. It was designed to
Your
process
mum's data rate is
super
insane.
and Vera was an incredible GPU. Grace was an incredible GPU. Now Vera increases the single-threaded performance, increases the capacity of the memory, increases everything just dramatically. It's a giant chip. This is the Vera CPU. This is one CPU. And this is connected to the Rubin GPU. Look at that thing.
Okay. That is
It's a
huge.
giant chip. Now, the thing that's really special, and I'll go through these. It's going to take 3 hands, I think, 4 hands to do this. Okay, so this is the Vera CPU. It's got 88 CPU cores, and the CPU cores are designed to be multi-threaded. But the multi-threaded nature of Vera was designed so that each one of the 176 threads could get its full performance. So it's essentially as if there's 176 cores, but only 88 physical cores. So these cores were designed in using a technology called spatial multi-threading. But the I/O performance is incredible. This is the Rubin GPU. It's 5x Blackwell in floating performance. But the important thing is go to the bottom line. The bottom line, it's only 1.6 times the number of transistors.
It's interesting that it's still only Blackwell GPUs. So they haven't advanced their chipset architecture. It's still on Blackwell.
At the level of basically every single chip across the
I mean,
entire system.
I've just bought a 5070 Ti, and that's on Blackwell. So they haven't really advanced that far.
1.6 times each year, because that's the total number of transistors you have. And even if you were to have a little bit more performance per transistor, say 25%, it's impossible to get 100% yield out of the number of transistors you get. And so 1.6x kind of puts a ceiling on how far performance can go each year unless you do something extreme, and we call it extreme co-design. Well, one of the things that we did, and it was a great invention, is called NVFP4 Tensor Core. The transformer engine inside our chip is not just a 4-bit floating point number somehow that we put into the data path. It is an entire processor, a processing unit that understands how to dynamically, adaptively adjust its precision and
Oh my God.
to deal
How are
with
people in the
different
audience at
transformers
CES not
so
just
that you can
falling
achieve higher
asleep,
throughput
for fuck's
wherever
sake?
it's possible
This
to
is
lose
just
precision,
AI
and to
bullshit
go
in its
back to the
most
highest possible precision
profound
wherever you need to.
bullshitness.
That ability to dynamically do that. You can't do this in software because obviously it's just running too fast. And so you have to be able to do it adaptively inside the processor. That's what an NVFP4 is. When somebody says FP4 or FP8, it almost means nothing to us. And the reason for that is because it's the tensor core structure and all of the algorithms that makes it work. NVFP4, we've published papers on this already. The precision, the level of throughput and precision it's able to retain is completely incredible. This is groundbreaking work. I would not be surprised if the industry would like us to make this format and this structure an industry standard in the future. This is completely revolutionary. This is how we were able to deliver.
How is it revolutionary? You're using a current Blackwell architecture.
Number of transistors. Okay, so this is, and now once you have a great processing node, and this is the processor node, and inside, so this is for example, here, let me do this.
800 gigabits a second Ethernet. That's actually quite impressive.
This is, wow, super heavy. You have to be a CEO in really good shape to do this job. Okay, all right. So this thing is, I'm gonna guess, this is probably, I don't know, a couple of 100 pounds. I thought that was funny too. Come on, it could have been. Everybody's going, no, I don't think so.
Okay, it's only on stage for another half an hour.
This is the last one. We revolutionized the entire MGX chassis. This node, 43 cables, 0 cables, 6 tubes, just 2 of them here. It takes 2 hours to assemble this.
Yeah.
If you're lucky, it takes 2 hours. And of course, you're probably going to assemble it wrong. You're going to have to retest it, test it, reassemble it. So the assembly process is incredibly complicated. And it was understandable as one of our first supercomputers that's deconstructed in this way.
Okay.
This, from 2 hours to 5 minutes.
There's no way you can assemble that in 5 minutes. Maybe 10, 15 minutes, but 5 minutes? Fuck off.
100% liquid cooled. Yeah, really, really a breakthrough. Okay, so this is the new compute chassis, and what connects all of these to the top of rack switches, the east-west traffic, is called the Spectrum-X NIC. This is the world's best NIC, unquestionably NVIDIA's Mellanox, the acquisition Mellanox that joined us a long time ago now. Their networking technology for hypercomputing is the world's best. The chip design, all of the interconnects, all the software stacks that run on top of it.
Still a little
their
bit
RDMA, absolutely,
I don't
absolutely bar none, the world's best. And now, to do programmable RDMA and data path so that our partners like AI Labs could create their own algorithms for how they want to move data around the system. But this is completely world-class, ConnectX. ConnectX 9 and the Vera CPU were co-designed. And we never revealed it, never released it until CX9 came along because we co-designed it for a new type of processor. You know, ConnectX 9, or CX8 and Spectrum-X revolutionized how Ethernet...
Fucking bullshit jargon, I swear to God.
Ethernet traffic for AI is much, much more intense, requires much lower latency. The instantaneous surge of traffic is unlike anything Ethernet sees. And so we created Spectrum-X, which is AI.
Life-changing, so introspective. I'm gonna tick that off as well because that's.
nVidia today is the largest networking company the world has ever seen. So it's been so successful and used in so many different installations. It is just sweeping the AI landscape. The
presentation failure. That I think that's happened as well, hasn't it? Hasn't it?
Megawatt data center, or if you have a gigawatt data center. These are billions of dollars. Let's say a gigawatt data center is $50 billion. If the networking performance allows you to deliver an extra 10%, in the case of Spectrum-X, delivering 25% higher throughput is not uncommon. If we were to just deliver 10%, that's worth $5 billion.
$5 billion.
Is completely free, which is the reason why, well, everybody uses Spectrum-X. It's just an incredible thing. And now we're going to invent a new type of data processing. And so Spectrum-X is for east-west traffic. We now have a new processor called BlueField-4. BlueField-4 allows us to take a very large data center, isolate different parts of it so that different users could use different parts of it, make sure that everything could be virtualized if they decide to be virtualized. So you offload a lot of the virtualization software, the security software, the networking software for your north-south traffic. And so BlueField 4 comes standard with every single one of these compute nodes. BlueField 4 has a second application I'm going to talk about in just a second. This is a revolutionary processor, and I'm so excited about it. This is the NVLink 6 switch, and it's right here. This is this switch chip. There are 4 of them inside the NVLink switch here.
Oh God!
Has the fastest SerDes in history. The world is barely getting to 200 gigabits. This is 400 gigabits per second switch. The reason why this is so important is so that we could have every
My
single
computer isn't
GPU
even
talk to
running
every other
on
GPU at exactly the same
2.5 gigabits. I'm
This
still on
switch-
like
this
1
switch
gigabit.
on the backplane of one of these racks enables us to move the equivalent of twice the amount of the global internet data. All of the world's internet data at twice the speed. You take the cross-sectional bandwidth of the entire planet's internet, it's about 100 terabytes per second. This is 240 terabytes per second. So it kind of puts it in perspective. This is so that every single GPU can work with every single other GPU at exactly the same time.
Okay.
Then on top of that, okay, so this is one rack. This is one rack. Each one of the racks, as you can see, the number of transistors.
It's still on Blackwell.
Is 1.7.
Why are they advertising Blackwell still?
Could you do this for me? So this is. It's usually about 2 tons.
Blackwell is current
Today
generation.
it's 2.5
I've got
tons
Blackwell in
because,
my
when
5070
they ship
Ti
it, they
that I've
forgot
just
to drain some
installed.
water out of it. So we shipped a lot of water from California. Can you hear it squealing? You know, when you're rotating 2.5 tons, you're going to squeal a little.
Oh, don't
could do
worry.
it.
I'm going to squeal.
Wow.
Only later.
Okay, we won't make you do that twice. All right, so behind this are the NVLink spines. Basically 2 miles of copper cables. Copper is the best conductor we know. And these are all shielded copper cables, structured copper cables, the most the world's ever used in computing systems ever. And our SerDes drive the copper cables from the top of the rack all the way to the bottom of the rack at 400 gigabits per second.
Okay, that's
It's incredible. And so
okay. That
this
just
has
looks
2
like
miles
some
of
kind of
copper
lighting
cables,
display.
5,000 copper cables, and this makes the NVLink spine possible. This is the revolution that really
Oh
started
God!
the NGX system.
Fucking hell, Jensen.
We
Fucking
decided
crack on with it.
that we would create an industry standard system so that the entire ecosystem, all of our supply chain, could standardize on these components. There are some 80,000 different components that make up these MGX systems, and it's a total waste if we were to change it every single year. Every single major computer company, from Foxconn to Quanta to Wistron, you know, the list goes on and on and on, to HP and Dell and Lenovo, everybody knows how to build these systems. And so the fact that we could squeeze Vera Rubin into this, even though the performance is so much higher, and very importantly, the power is twice as high. The power of Vera Rubin is twice as high as Grace Blackwell. And yet, and this is the miracle, the air that goes into it, the air flow is about the same. And very importantly, the water that goes into it is the same temperature, 45 degrees C. With
Fuck's
45 degrees
sake.
C,
Nobody
no
gives a shit about the fucking water
chillers are
temperature.
necessary for data centers. We're basically cooling this supercomputer with hot water. It is so incredibly efficient.
Okay,
So
okay, whatever.
this is the new rack. 1.7 times more transistors, but 5 times more peak inference performance, 3.5 times more peak training performance. Okay?
Jesus.
They're connected on top using Spectrum X. Oh, thank you.
nVidia Spectrum
This is
X
the world's
Ethernet
first
code
manufactured
package
chip
optics.
using
Fucking Jesus
TSMC's
Christ.
new process that we co-innovated called COOP. It's a silicon photonics, integrated silicon photonics process technology. And this allows us to take silicon photonics directly right to the chip. And this is 512 ports at 200 gigabits per second. And this is the new
200
Ethernet
gigabits.
AI switch,
That's not
Spectrum
bad.
X Ethernet switch. And look at this giant chip. But what's
It's not
really
bad at
amazing
all,
is it's
actually.
got silicon photonics directly connected to it. And lasers come in. Lasers come in through here. Lasers come in through here. The optics are here, and they connect out to the rest of the data center. This I'll show you in a second, but this is on top of the rack.
Okay.
And this is the new Spectrum X silicon photonics switch. Okay? And we have something new I want to tell you about. So just as I mentioned, a couple of years ago, we introduced Spectrum X so that we could reinvent the way that networking is done. Ethernet is really easy to manage, and everybody has an Ethernet stack, and every data center in the world knows how to deal with Ethernet. And
I am still on Ethernet
at the time was called
1000
which is used for supercomputers. InfiniBand is very low latency, but of course the software stack, the entire manageability of InfiniBand is very alien to the people who use Ethernet. So we decided to enter the Ethernet switch market for the very first time. Spectrum X, that
Of course you
just
did.
took off. And
You're
made
trying.
us
You're
the
trying to get
largest
into
networking
every
company
kind of
in the world,
market with.
this next generation Spectrum is beyond that tradition. But
I
just
mean,
as
I'm okay
I
with
said
this because
earlier, AI has reinvented the whole computing
nVidiaa's
stack.
a pretty decent
Every layer of the
company.
computing stack, it stands to reason that when AI starts to get deployed
Fucking
in these
AI
large
again.
enterprises, it's gonna
AI this,
also
AI
reinvent
that.
the way
Fuck,
storage is done.
fuck's sake.
Well, AI doesn't use SQL. AI uses semantics information. And when AI is being used, it creates this temporary knowledge, temporary memory called KV cache. Key value combinations, but it's
AI.
a KV cache, basically the cache of the AI.
I can't
the
take
working
any
memory
more
of the
AI.
And the working memory of the AI is stored in the HBM memory. Every single token, for every single token, the GPU reads in the model, the entire model. It reads in the entire working memory, and it produces one token. And it stores that one token back into the KV cache. And then the next time it does that, it reads in the entire memory, reads it, and it streams it through our GPU, and then generates another token.
Yeah,
well,
I love those tokens.
Token after token.
Love those
And
token after
obviously,
token.
if you have a long
Yeah.
conversation
What the
with
fuck are you
AI,
talking
over
about?
time, that memory, that context memory, is going to grow tremendously. Not to mention the models are growing, the number of turns that we're using the AIs are increasing. We would like to have this AI stay with us our entire life and remember every single conversation we've ever had with it, right? Every single lick of research that I've asked it for. Of course, with the number of people that will be sharing the supercomputer is going to continue to grow. And so this context memory, which started out fitting inside an HBM, is no longer large enough. Last year, we created Grace Blackwell's very fast memory. We call it fast context memory. That's the reason why we connected Grace directly to Hopper. That's why we connected Grace directly to Blackwell, so that we can expand the context memory. But even that is not enough. And so the next solution, of course, is to go off onto the network, the north-south network, off to the storage of the company. But if you have a whole lot of AIs running at the same time, that network is no longer going to be fast enough. So the answer
You know what?
is very
I'm
clearly
gonna drink my
to do it
Huel
different. And so
because
we created
I'm hungry
Bluetooth 4
and
so that
I
we
don't want
could
to eat
essentially
anything
have
too
a
crazy.
very fast
So I'm having my
KV
Huel.
cache context memory store right in the rack. And so I'll show you in just 1 second, but there's a whole new category of storage systems. And the industry is so excited because this is a pain point for just about everybody who does a lot of token generation today. The AI labs, the cloud service providers, they're really suffering from the amount of network traffic that's being caused by KV cache moving around.
You know,
and so the idea that we would create a new platform, a new
there's only
processor
20 minutes
to
left
run
of
the
your
entire
keynote speech.
Dynamo
I am very, very
KV
close
cache
To you
context
talking
memory
about,
management
to my
system,
prediction of
and
you
to put
talking
it
about
very
AI
close to the rest of
for
the rack,
2
it's
hours
computing
and only
revolution.
like
So this is
5
it.
minutes of
This is
GeForce
sits
and
right here.
consumer electronics.
So this is all the compute nodes. Each one of these is NVLink 72. So this is Vera Rubin NVLink 72, 144 Rubin GPUs. This is the context memory that's stored here. Behind each one of these are
Use the
four
code
blue
Jessica
fields.
Carver
Behind
case if
each
you
blue
want
field is
15 to 20% off
150 terabytes.
a Huel order.
150
Give it a go
terabytes of memory, context memory.
on the
And
Huel
for
website.
each
by the
GPU,
way.
once you allocate
Jessica
it across,
Carver case is the
each
code you need to
GPU will
use.
get an additional
Give it a go.
16 terabytes. Now, inside this node, each GPU essentially has 1 terabyte. And now, with this backing store here, directly on the same east-west traffic, at exactly the same data rate, 200 gigabits per second, across literally the entire fabric of this compute node, you're going to get an additional 16 terabytes of memory, okay? And this is the management plane. These are the Spectrum X switches that
Right.
connects all of them together.
Okay.
And over here, these switches at the end
I'm still
connects
kind
them
of
to
ill.
the rest of the data
Sorry.
set. Okay? And so this is the Vera Rubin. Now, there's several things that's really incredible about it. So the first thing that I mentioned is that this entire system is twice the energy efficiency, essentially twice the temperature performance, in the sense that even though the power is twice as high, the amount of energy used is twice as high, the amount of computation is many times higher than that, but the liquid that goes into it is still 45 degrees C. That enables
I can
us
see
to save about 6% of
the
the world's data
pixels
center
of
power.
the,
So that's a very big
of
deal.
the red display
Second very big
behind
deal
you, Jensen.
is that this entire system is now confidential computing safe, meaning everything is encoded in transit, at rest, and during compute. And every single bus is now encrypted. Every PCI Express, every NVLink, every NVLink between CPU and GPU, between GPU to GPU, everything is now encrypted. And
Okay.
so it's confidential computing safe. This allows companies to feel safe that their models are being deployed by somebody else, but it will never be seen by anybody else. Okay? And so this particular system is not only incredibly energy efficient, and there's one other thing that's incredible. Because of the nature of the workload of AI, it spikes
Fucking
instantaneously
AI!
with this computation
Focus.
layer called
Jesus
on-use.
Christ.
The amount of current, the amount of energy that is used simultaneously is really off the charts. Oftentimes, it'll spike up 25%. We now have power smoothing across the entire system so that you don't have to over-provision by 25 times, or if you over-provision by 25 times, you don't have to leave 25%, not 25 times, 25% of the energy squandered or unused. And so now you could fill up the entire power budget, and you don't have to provision beyond that. And then the last thing, of course, is performance. So let's take a look at the performance of this. These are only charts that people who build AI supercomputers would love. It took every single one of these chips, complete redesign of every single one of the systems, and
God, it's
rewriting
so
the
good.
entire stack for us to make this possible. Basically, this is training the AI model, this first column. The faster you train AI models, the faster you can get the next frontier out to the world. This is your time to market. This is technology leadership. This is your pricing.
Nobody
And so
fucking
in the case
cares.
of the green, this is essentially a 10 trillion parameter model. We scaled it up from DeepSeek. DeepSeek, that's why we call it DeepSeek++. A training a 10 trillion parameter model.
God,
on
Jensen,
100
fuck's
trillion
sake, come on.
Tokens. Okay? And this is our simulation projection of what it would take for us to build the next frontier model. The next frontier model, Elon's already mentioned that the next version of Grok 5, I think is 7 trillion parameters. So this is 10. And in the green is Blackwell. And here in the case of Rubin, notice the throughput is so much higher, and therefore it only takes 1/4 as many of these systems in order to train the model in the time that we gave it here, which is 1 month.
I mean,
and so
that looks impressive.
Time is the same for
but
everybody. Now,
considering you
how
said
fast you can train that model and how large of a model you can train is how you're going to get to the frontier first.
Considering that you
is your
said
factory throughput.
4090
Blackwell
performance
is green again.
in
And factory
the
throughput is
5070
important because
last
your
year,
factory is, in the case of a
how would I
gigawatt,
believe
is $50
anything you
billion.
say right
A
now?
$50 billion data center
You know what I mean?
can only consume 1 gigawatt of power. And so if your performance, your throughput per watt is very good versus quite poor, that directly translates to your revenues. Your revenues of your data center is directly related to the second.
Oh God, it's
And in
nothing
the
but
case of
AI data
Blackwell,
centers and
it was
AI
about
bullshit.
10 times over Hopper. In the case of Rubin, it's going to be about 10 times higher again. Okay? And in the case of now, the cost of the tokens,
I'm a bit bloated
cost
right now.
effectively it is to generate the token.
I'm very bloated,
This
in
is
fact.
Rubin about 1/10.
With all the
Just
alcohol
as in
and
the case of-
the fuel.
Yep.
Stop clapping!
So this is how we're going to get everybody to the next frontier, to push AI to the next level. And of course, to build these data centers energy efficiently and cost efficiently. So this is it. This is NVIDIA today. You know, we mentioned that we build chips, but as you know, NVIDIA builds entire systems now. And AI is a full stack.
Fucking AI,
We're
for fuck's sake.
reinventing AI across everything from chips.
The bubble's gonna burst
infrastructure,
eventually.
to models,
How can you
to
not see it,
applications.
Jensen?
And our job is to create the entire stack so that all of you could create incredible applications for the rest of the world. Thank you all for coming. Have a great CES. Now,
I'm sorry, what? You're not
going
gonna say anything about GPUs for the consumer?
Slides we had to leave on the cutting floor, and so we have some outtakes here. I think it'll be fun for you. Have a great CES, guys.
Fucking nothing about GPUs for the consumer. No Super Series, no nothing.
NVIDIA Live at CES Take 4 Marker.
Boom mic.
Do you know what? I think it's because they know that I think it's because they know that they've absolutely fucked the consumer market because they are taking all the RAM, using it for AI. So they've completely fucked the consumer market because no one can buy memory for their computers because they're using it for all the AI stuff. Okay, I'm a little bit drunk. I'm slurring my words a little bit, but I think this is the first time NVIDIA haven't done any consumer GPUs, and it's the reason is because they've completely fucked the consumer market with RAM, that they can't do the 50 series Super series, the NVIDIA RTX 5000 series. They can't create any Super series of that. You know what I mean. You know what I'm talking about. Fucking outtakes. No one gives a shit about outtakes, pal. Ugh. God damn it. What a fucking piss take. Well, might as well get rid of this. Christ's sake. Okay. Let's get rid of that. And let's see if I can find the Intel CES. because Intel are due to start at 11 at CES. Oh, Jesus. Sorry. Okay. So Intel are on in 10 minutes. Oh my god, I'm so sorry. I'm still very ill. So Intel are due to start in 10 minutes time at 11 o'clock. So we're going to stay here and see what Intel has to offer. Hopefully they're going to announce some new GPUs. So yeah, we'll see what happens with Intel. Oh, fucking hell. But yeah, nVidia, very disappointing. It was all about it was literally 2 hours of AI bullshit. Nothing for the consumer market. And considering a lot of people in the professional industry actually use consumer GPUs for their video editing and you know, that kind of thing, I think it's a very, very poor show for nVidia. But that's their own fault for like lapping up all the memory chips, which means they've caused a memory shortage, which means no one can buy nVidia G. Sorry, I still have bronchitis from my flu virus. You know what I'm talking about. Oh my god, that's so good. Oh god, I'd love to. I'd love to drink another one of those, but I'm not going to because I'm not a crazy person. Okay, 9. Jesus Christ, 9 minutes. I am going to be back in 9 minutes. I'm just going to go take a piss, do a few other bits in preparation for Intel's CES event. So join me in a oh my god, fuck, sorry. Right, let's do some so how long is this? 8 minutes. So I've got a 8 minutes. There's got to be something I've got for 8 minutes. No, there isn't. There's got to be something. 4 minutes. Okay. Okay, I'm going to play this for 4 minutes. I'm going to go take a piss. And I will see you in about 4 minutes time. Well, 4 minutes 17. Okie dokie. Let's close the door. Jesus. How do you like my fit, by the way? Does it look good? Does it look okay? Kind of cute, right? Right. I think so. Okay, so we're watching the. Oh my god! I'm so sorry. I am still quite ill. Oh. Okay. See if I can find. Okay.
Make bold moves.
Oh yay! Adverts, fantastic. There we go. Okay, 40 seconds apparently. 40 whole seconds. I'm not entirely sure why. Oh, there we go. Oh, okay, we've got two different chats going on here. Oh shit. Okay. Come on, Intel. Let's see what you got for us.
Please welcome Chief Executive Officer Lip Bu Tan.
Oh, do we have to have the fucking subtitles? Jesus. Do better than nVidia. You will be absolutely applauded.
And welcome to CES. And thank you for joining us today. It is an honor to be here with so many innovators, creators, customers, and partners from around the world. We are living in a moment where compute is being redefined. AI is reshaping every workflow, every industry, and
Only because of
every
nVidia.
device, from cloud to edge. At Intel, our mission is to make that intelligent, accessible, efficient, and ubiquitous. Over the last year, our team have pushed the limits of architecture, fabrication, and co-optimization across hardware and software. I'm pleased to share that we have delivered our commitment on shipping our first 18A products by the end of 2025. In fact, we are over-delivered. I'm delighted to announce that we are ramping all three Core Ultra Series 3 die package as we speak. What you will see and hear later today are breakthroughs that can only be enabled by a tight integration of silicon design, advanced process, silicon process, and packaging technology. It is something that only Intel is uniquely positioned to do, working closely with our OEM partners and the open ecosystem. You will hear from Jim later on, and his team talk more about all the technology we are announcing today. Our latest Series 3 based system truly represent a new class of computing, designing for AI-driven future.
Fucking AI!
Empower
Come on!
developers and creators and engineers to drive then deliver massive leaps in performance and efficiency. This announcement will representing the next evolution of the PC. So thank you for joining us. Let us talk about what is next and show you what is possible. Thank you.
All right, let's see what's possible. It's all bullshit AI again.
Every breakthrough begins with silence. A moment of focus. A moment of building in the quiet. But in that quiet, inside these fabs, the momentum has been rising. See, quiet doesn't mean stillness, because here, progress never pauses. It pulses, pushes, accelerates.
Okay.
Layer by layer, line by line, gate by gate. And now, it's ready to meet the world.
Who the fuck makes this
Progress
fucking audio?
never pauses. And neither do we.
Intel Core Ultra
Please
Series
welcome
3.
Senior
Okay.
Vice President, General Manager, Client Computing Group, Jim Johnson.
Jim Johnson. Hi, I'm Jim Johnson.
2026. I'm excited to be leading the Client Computing Group PC and Edge products at one of the most exciting times in the industry and for our company. CS holds a special place in my heart because together we get to set the tone for what's coming this year. A special welcome to our partners. Thank you for coming and spending the time with us. You know, we could not do it without you. This partnership is what delivers. But before we talk about client, let's stop for a second and talk about Intel.
Okay.
The industry and Intel are both at a strategic inflection point. In 2026, we're delivering leadership products on a leadership process node, combining compute, graphics, and AI, and scaling it with customers to be the broadest AI PC platform together we have ever built. In the last 5 years, we've invested heavily in capital, R&D, new fabs, new tools. Much of this investment aimed at pushing process technology forward, expanding manufacturing capacity in the United States and around the globe. 18A is the center of that effort. As Lip-Bu mentioned, we're in production and ramping.
You know, I think nVidia, I think Intel, I can't believe I just said nVidia. I think Intel are going to come back in a big way. They've been out of the loop for like a few years, but I think they're about to come back in a massive way, especially in GPU.
That provided our architects a way to precisely control
in the
electrical
GPU
current,
market,
critical for performance and energy efficiency. Backside power delivery via PowerVia enhances power flow and signal delivery. What's this mean? It enables Intel to deliver up to 15% better performance per watt with more than 30% better chip density. This was not an easy task, but we executed to our plan and we're ramping to our
I mean, the only way you can get better chip density is if you reduce the nanometer nodes.
of Intel.
I think currently they're about
Alongside delivering
4 nanometer.
at unmatched scale,
You need to reduce it to like 1 nanometer,
to drive power-efficient
and then we're
performance,
entering the sort of realm of
hybrid core
quantum computing.
architectures, and a multi-engine local AI are coming to life. We build for what's needed today, but work really hard with our partners to anticipate what's required next.
Yeah.
And right now, as we know, that next wave is AI. It's everywhere.
Of course it's fucking AI. Why wouldn't it be AI? It's nothing but fucking AI.
It's a huge opportunity for all of us, and together we've been out front shaping what it means for personal and edge computing. And with all the excitement around AI, we always remind ourselves fundamentals still matter. Everybody wants a cool, quiet PC, strong performance, all-day battery life when we're on the go. And
I've got a cool, quiet PC, and I'm quite happy with it. Sexy.
This is Core Ultra Series 3.
Why is it fucking oblong?
The first processor built with 18A technology, the most advanced process in the world.
In the world.
We've taken big steps in improving our major SoC IPs in virtually every piece of the chip design.
Yeah.
Bringing the latest and greatest on all fronts. We have new E-cores.
I feel so fat right now.
P-cores, a
I drank too much, I
GPU
think.
built-in ray tracing, and an
Never
NPU
mind.
that packs more low-power AI in a very dense area, much denser than prior generation. Next-gen memory, next-generation I/O,
Nice tits, though.
and the latest connectivity, wired and wireless. These were all done to achieve a primary goal with our partners to scale power efficiency leadership,
Okay.
performance across all workloads,
Okay.
expanding our graphics capability, I can't wait till you see this, and enabling a broader set of devices with our OS partners, with our ODM partners, our OEM customers, and importantly the ISV community.
Oh, Jesus.
Together, we've nailed these goals with Core Ultra Series 3. Achieved by combining the performance and power efficiency we launched across our Series 2 family of processors into one single product.
x86 power efficiency.
And this isn't marketing.
Who's on
We are showing how
x86?
CPU
Everyone's on
architecture
x64 right now. What the fuck?
through our fabrics and with our 18A process node. We've used the power efficiency of Lunar Lake as the architectural foundation of Series 3 and our roadmap moving forward. The graphics performance was already impressive, but we wanted to expand performance available across more devices. We've moved the GPU tile to its own chiplet. And now we can
Nice.
attach larger or smaller chiplets based on the market segment needs and the device needs of our customers. We're continuing to push through our hybrid core strategy,
Yeah.
redesigning cores for 18A so they operate at significantly lower voltage.
Yeah.
It means greater per core performance while increasing efficiency.
Okay.
We've improved the multi-threaded performance of Series 3 by adding up to 8 E-cores, and we completely redesigned our low-power island with dedicated low-power E-cores with their own cache.
I mean, it's been a while since I've been on an Intel platform.
Examples like web browsing and video
Maybe
conferencing that demand power
more than 8 years.
The benefit?
So I don't know
Better
what an
performance,
Intel platform's like at
much
the
lower
moment in the
power,
current generation.
longer battery life.
I'm currently on an
We've
AM4
also
platform, which is
consolidated
AMD.
all the IOs onto a single chip. This was a big ask by our customers' design teams because they want to take Series
Oh, I
3
like that 20
and expand
PCIe
its
Express
capabilities
lanes.
and its market coverage. but people don't buy SoCs, and we know that. So beyond the SoC, we've deployed other technologies at the platform level focused on power efficiency. Intel's intelligent display technology, context-aware charging, low power video conferencing with our image processor, long-lasting connectivity with Intel's Wi-Fi solution. We bring this all together with our advanced Foveros packaging technology, delivering a full range of Series 3 processors. That architecture flexibility allows us to provide multiple configurations using a single package type up and down our customers' designs, something they've been asking for 2 generations. They have more memory options, and they now can use their own power delivery schemes for their product management and product capability. This gives them design flexibility up and down their product lineup, supporting them into the market and easing design efforts for their teams. So we just covered a lot on architecture. Let's unpack what it can do, starting with the x86 core. We're proud of this accomplishment. Core Ultra Series 3 delivers 60% more performance than Lunar Lake Series 2. And it's faster and more efficient than our highest performing SKU, running fewer P-cores. This focus, this maniacal focus our design teams have on power efficiency and the implementation of the low power island dramatically improves a range of applications we use every day. A simple example would be streaming 4K video on Series 3 draws now 1/3 the power than prior generations. A massive reduction that allows us to be talking about battery life in days, not in hours. It once again puts the myth to bed that x86 can't be power efficient, even at higher performance levels. And this is the last time I'm going to say
Again, this is x86. It's not x64, which is what most computers run on these days.
So let's switch gears and now talk about the GPU, arguably the biggest update to Series 3. And to walk you through it, let me welcome our GM of PC Products, Dan Rogers, to the stage. Thanks, brother.
Thanks, Jim. Graphics at Intel is an interesting history. Ubiquitously deployed.
Intel Arc, here we go.
Massive install base.
Are you going to completely fuck NVIDIA?
Lacking in key features, driver support, and frankly, performance. 5 years ago, we set on a mission to change that.
Yes.
With the announcement of our Intel Arc graphics.
Yes.
And this was more than a hardware plan. Arc is our brand commitment to deliver world-class, discrete-class software across a range of graphics products, including integrated. We've re-architected our entire software stack and strategy to include extensive game day testing, day zero driver support,
yes,
and a full modern feature set. Last year alone, our engineering teams engaged 300 developers on pre-release titles and supported 50 day zero driver releases. This is light years ahead of where we were just a few years ago. And you've seen the results.
Wow, really?
With Lunar Lake and then Battle Mage, one of the best reviewed cards of 2025.
Battle Mage is pretty good.
And
I'm
so
gonna
today,
be
we are
honest.
very proud to announce the next generation integrated GPU we've been referring to as 12xe.
I don't care about integrated GPUs. I want discrete GPUs.
It features 50% more graphics cores, twice the cache, and 96 built-in XMX AI accelerators for 120 GPU tops. If you were impressed by the graphics of Lunar Lake, Panther Lake has 70% more gaming performance and an incredible 50%
Nice.
more AI inference performance.
Nice.
And to prove it, we tested Panther Lake across a range of titles and APIs from DX9 to DX12. And as you can see, the new Arc GPU not only delivers a consistently smooth gameplay, but when compared to the latest from AMD Radeon,
Yeah.
with similar power and similar memory, delivers an incredible 70% higher frame rate on average,
Yeah.
and 2x faster on select titles. This is truly amazing. As an example, first-person shooters such as Painkiller and Delta Force will play at well over 100 frames per second with 1080p high settings and XeSS super resolution. To the developers and engineers at Intel and partners across the industry, thank you. Through your hard work, millions of PC gamers will be able to experience
Why are his
great
eyes so
industry-class
green?
game performance on a thin and light laptop for the first time in 2026. But as impressive as this performance is, in a way, it's a look only at today. This is traditional raster performance with AI upscaling.
XeSS3,
What's
so
unique
that's
about our
pretty
graphics
much
is that we
DLSS,
built
right?
this for the future, and we call this modern rendering. This means better lighting with ray tracing or other demanding visual settings. Sharper visuals with high-quality textures and larger geometric assets, and the ultimate in smoothness through AI-generated frames. Today,
Yeah,
we're
so it's
excited
like
to confirm
DLSS.
that the new Arc graphics in Panther Lake will be the first integrated graphics ever to ship day one with AI-based multi-frame generation, delivering
Yeah,
3
don't
AI-generated
game
frames
with multi-frame
for every
generation
one
if you can
rendered
help
frame.
it. It ruins quality. Don't do it.
Thank you. It's a big moment for our
What
graphics
they're
team.
basically doing,
A great example of the benefits
like
of these
nVidia,
is Battlefield
AMD,
6,
and
which
Intel,
just launched
what they're
early
basically
March.
doing is
Intel
they're
has been working with EA closely, the
replacing
developers of Battlefield,
raw power
to unleash
with
the full
AI
performance of this
generated
title on our
bullshit.
graphics.
So instead of generating genuine
demanding
frames, they're using
offered in a game
AI
called
to fill in
overkill
the
settings.
frames that you
Arc
are
V390
missing
can already drive a smooth
with
experience
AI
with
generated
smooth frame rates
frames,
using
and it
super
means
resolution.
that
But as we turn on
you're
multi-frame
getting
generation
more
in the
frame
driver,
rate,
you
but
can
you're
see that we can
getting
scale to
less
an incredibly
quality
smooth
because you're getting
experience.
like artifacts and
120 frames per second
movement issues and
and
all
nearly
that kind of thing
3
because
times
AI
faster
can't keep up
than
with the
AMD.
fact that, you know,
To share more about this collaboration
raw
between
gaming
EA and
power
Intel,
is
I'm very
what we
honored to
need
invite
as
fellow
as
and
as,
VP of
as
Technology
gamers.
Partnerships at EA, Jeff Skelton, to the stage. Please welcome Jeff.
Fucking hell, how many people do they need on stage in this fucking nVidia thing?
Jeff,
Intel
thank you for
thing.
joining us today.
Jesus.
Pleasure to be here.
So we just walked through the incredible performance.
Oh
of
my
Panther
god, it's
Lake
so
Arc
awkward.
graphics.
Why is
What
this
your
so
perspective of this
awkward?
collaboration between EA and Intel?
Absolutely. So we set out to build the best Battlefield ever by reimagining this iconic franchise from the ground up, pushing the limits of large-scale multiplayer and tactical destruction experiences while redefining the FPS genre. We want all players to enjoy this amazing experience. And a partnership like
If
this
it's
one,
60 frames per
like
second,
the one
I
we
don't
have with
care.
Intel, helps us achieve
If
that
it's more than
best
60 frames per
frame
second,
rate,
couldn't give a
style
shit.
stability, and more.
60
This work
frames per
ensures
second is
that we meet
absolutely
player
fine.
expectations, whether they are running desktops with discrete GPUs or mobile processors like Panther Lake. You know, I've been making games for a very long time. And if you told me a few years ago I'd be up here on stage with Intel talking about how our games run and how well they run on integrated graphics, I wouldn't have believed you. The performance we see on Panther Lake is remarkable.
Yeah, thank you, Jeff. This means a lot from you and the team at EA. Our engineers have been working with EA for the very beginning of Panther Lake, from the first A0 silicon, to ensure a robust driver support at their beta as well as launch. We had two key focus areas. One was optimizing for the hybrid CPU architecture that we've had since Alder Lake, and two, implementing the latest AI-based XeSS technologies into the title.
Okay.
The addition of AI
I've
to
never
the
played
front
Battlefield
has
6,
been a
but
game changer.
whatever.
At this point, I don't think you'd want to build a game without technologies like XeSS.
Anything else coming, Jeff?
Absolutely. We're working on a native integration of XeSS 3 as we speak. Stay tuned.
Jeff, thank you so much. We're so excited to see what's next from EA.
Thank you so much.
You came on stage just to say fucking.
And finally, with the performance of our graphics integrated into a low-power x86 SoC, plus the progress you've just seen in software from Intel, It's natural that we would think even beyond laptops.
What the hell is that?
So today, we're excited to share with you that we'll be launching an entire handheld gaming platform.
Really?
And we'll have more news to share on that from our hardware and software partners later this year. I hope you stay tuned. Thank you so much.
Really? Intel are doing a handheld gaming? I hope that's not the system. That looks awful.
If you have any interest in mobile gaming, you've got to buy that PC. So now let's turn our attention to AI. To deliver
For
new and
fuck's
better
sake.
experiences of AI PCs, it takes a massive investment by our software partners.
Okay, I don't think I can sit through another 20, 30 minutes of AI bullshit. So I'm just going to end it here.
Our hardware and infrastructure and the
Yeah, I'm not going through another fucking 20 minutes of AI, so
software ecosystem.
fuck off. No, thank you. I'm sick of hearing about AI. That's the problem with companies at the minute. It's just AI.
That would ultimately
Yeah,
deliver.
they don't realize that people that actually use their graphics cards as a consumer in the professional space are just not getting the benefit. You're putting all your money into AI for the government and all that kind of thing. Not even mentioning the fact that people, the companies that are actually putting money into AI are in debt because of the whole AI thing. It's going to end badly. It really is. It's going to end badly. Anyway, you know what? I'm going to end the stream here. Because I need to go to sleep. And I'm kind of drunk. So it's been interesting to see nVidia not give a fuck about gamers. And Intel just being semi sort of decent-ish. I might stay. Okay, AMD are due to be on stage at 2:30 GMT. I might stay up for that, but I'm not going to record it on stream because it's pointless. But I'll give you my thoughts on through social media. But other than that, I'm going to say goodbye. So thank you for watching. I'm kind of glad the stream didn't just sort of stop. And I thank you very much for watching. Again, if you want to try Huel, use the code JessicaCarcasey at Huel.com. You'll get, I think it's £15 or $20 or something off the thing. Apart from that, please enjoy. I don't know what I'm talking about. Just fuck it. Hopefully by the next stream I won't be so ill. So yeah, thank you very much for watching. That person who's just joined the stream, I do apologise. I'm just about to kick off. So thank you very much. Thank you very much for watching, and I will see you very soon.